Hello dear viewers, today we're going to have a contest again. And also we're going to have quite a few duels. We're going to have quite a few duels. So I'll try to list them. Okay. So I'm definitely having a duel with Capt, with Orbless, with Pilterator if he agrees to participate. Oh my god. My camera is constantly letting me down. Also Scanhex of course, maybe Fast Math if he agrees. And Sava CSK. Is Trumax participating? Unfortunately, no. Oh my god. Camera. I think I'll need... I think I'll have to buy a new camera. Well, for now that's it. So am I prepared? Yes. The only thing that is not prepared is my camera, which is constantly... Yes. Which is constantly doing this. "28 seconds. Actually, I'm very sleepy today because I woke up at 5:45 a.m. So 12 hours ago, something like this, and I'm not fresh. But this is no excuse. I need to participate in the duels. So let's go. This is unfortunate. So we can choose two non-adjacent lamps that are currently turned off and then turn them on. Okay, so we need to check we need to check that either, first of all, we need to check that the number of turn on lamps is even. And first of all, if there are exactly two of them, then they are not adjacent. So if on %2 return false, if on is not true, return true, return mx minus mn is at least 2. So let's make some tests. So the last one should be no. Yes, no, yes, no, yes, no. Codeforces rating. Funny. So I can swap my cow with any cow, and I want to maximize the number of won matches. So to win matches, I actually just want to be as early as possible. Yes? No, actually. So, what do I want? Yeah, so here is my cow. So if I won a match, then I won all matches before that match. So actually I need to check two things. I either need to swap my cow with the first cow, or maybe I need to do nothing, or I need to swap my cow with the first cow which is greater than me. Okay. So find ans. Oh, I read n and k. Then I read all integers a. Also, I think I need to decrement k. And I need to print the answer. So first of all, let's make int find naive answer. So what do? We go through all numbers, so from 1 to n. So if I need to say that w is maximum of w and ai, and if w equals ak plus plus ans. Like this. And here I need to say that first of all I need find naive ans of a and k. Then I need to swap a0 and ak. And again find naive ans of a and this time 0. Then I need to swap them back actually. So if a int is greater than ak, then break. And if int is less than n, then swap a int ak, and answer is maximized, is relaxed by a int. Do I need to? Yeah, let's try to do something. So I want to make a test where I have here, for example, 6. 1, and for example 4, 10, 0, 1, 2, 3. So I definitely want to swap myself. No, 6. So I want to swap myself with 10, so I win 1, 2, 3, 4 duels. Yes, maybe this is fine. Well, that's great. We are now 49th. Why is here Amogus? I don't understand this problem. This is a hard problem. So we need to buy K tickets, which is almost 10 to the 9th power. So actually, if I want to buy some tickets during some day, so first of all, if I have a day during which the tickets are less expensive than all next days, then we want to buy maximum possible tickets during this day. It's hard to tell what I should do. So actually what this system says, it says that you want to buy, I don't know what it says actually. Okay, let's say that if we buy a ticket, then all subsequent tickets, their prices are increased by 1. Then it says that actually if you buy a lot of tickets during the same day, then you're good to go, because instead of increasing, so actually, yeah, if you buy several tickets during the same day, then instead of your price getting as p plus 1, etc., p plus x minus 1, it is p, etc., p. So you get this economy. So we just want to maximize our economy, so we want to maximize the number of days during which we buy this number of tickets. And this simply means, what does this simply mean? This simply means that we want to minimize the number of days during which we buy tickets. Well, so the solution is straightforward now. So what do we have? We have n, m, and k. Then we have vi, a, n. Then we read llans is find dance a mk, and we print it. So what do we do here? We need to sort the array A. So then we need to go through it. So first of all, we will have to spend k times k minus 1 over 2. Okay. Then let's go. So we need to go through. Is it possible? Is it always possible to? K is most minimum of an m. Yeah, it is always possible. So let's go through this array. So what do we want to say? If k is 0, then break. Int by is minimum of k and m. Then we say that we get by times a times I. Then we say that we get an economy of size by times by minus 1 over 2 and k minus equals by. So that's it, actually. Return out 1064 172. Yes. Did I always use long? Here? No, I didn't always use long. This is stupid of me. Okay, we're good. Bind jewels. What is a stall? Okay. So Bob makes at most 60 stalls, and he needs to make Alice by exactly k jewels with some greedy procedure. So she goes to stall 1, buys as many as possible, then goes to stall 2. So first of all, if the number of coins of Alice is less than k, then she is unable to do it. So let's assume that Alice has at least k coins. Then we still have quite a problem, because, for example, if Alice has 8 coins and she needs to buy 7 jewels, I can't find a way how she could spend so little. Yeah, because this means that she needs to buy... Okay, I think the general procedure is as follows. So if n is at least k, then Alice buys one giant jewel, and then she spends the rest of the money on the rest of the jewels. So we want to make just two piles. One is n minus k plus 1, and then a lot of that which cost 1. So the question is, does it work? So it works if n minus k plus 1 times 2 is less than n. If this is true, then it works. And also if n equals k, we can just say, take 1. So let's check. Assume that this is... Assume that it is not true, so n minus k plus 1 times 2 is at least n. It means that 2n minus 2k plus 2 is at least n, which means that 2k is at most n plus 2, so k is at most n over 2 plus 1. So does it mean that Alice always loses if k... Let's say n. In terms of n, n is at most 2n minus 2. Does it mean that Alice necessarily loses? I don't know. Screencast says that he doesn't want to solve this anymore. That's unfortunate. So n is at most 2n minus 2. Is it true that Alice cannot do it? So n is at most 2k minus 2, but n is at least k plus 1. So that, does this mean that Alice loses? So the first coin cannot be 1. So this is at least 2. So Alice definitely... So let's take the first stall that Alice can buy. Then there are T coin. The cost is T there. So Alice spends at least n minus T coins. This means that T should be at least n over T n minus n over T. So this should hold. T should be at least n minus n over T. Okay, so let's say that n equals pt plus q, where q is less than t. Then we need to have that t is at least pt plus q minus p. What? I think we can just say that this is at least n over 2. So we know that t is at least n over 2. And what does that mean? So actually this means that here this is either 1 or 2. No, t is at least n over 2, so this is definitely 1. So t should be at least n minus 1. And this is bad. What? I don't understand. This is because this inequality does not hold? Again, so what do I want? I want so if the first thing is t, then I buy n over t jewels, and then I can buy at most n mod t. And this should be at least k. Yes, however, so again, let's say that n is pt plus q. So we see that this is p and this is q. And this should be at least k. So since this should be at least k, this should be at least n plus 2 over 2. So either this is big or this is big. So actually I can say that almost always this is at most PQ, and PQ is less than... Oh my god. Okay, let's just try saying that this is necessary. I don't know. I really don't know. I don't want to spend a lot of time on this. If we look here, I think we will see 41 solvers, so we cannot afford spending so much time. Okay, so I believe that what do we need to do? If n is less than k, we need to return nothing. So if n equals k, we need to return 1. If n is at least 2 times k minus 1, we need to return n minus k plus 1, and then 1. And finally, we need to return nothing. So let's try this. So in the first case, 25, 1, what? Ah. 2, 5, and 1. And yes, we've spent 5. Five, 1, 1. Here it is impossible. Here we spent 248. And then a lot of ones, 7 ones. Okay, 5, 4, 6, 4 are impossible. 7, 4 is just 2, 4, 1. And here 2, 3, 1 was not possible. Okay, let's try this. I think this can be a wrong answer, but if this is a wrong answer, we will have to solve this problem. Spend more time on it. Well, maybe this is correct. So problem E and maybe problem G. No palindromes. We have a string S of lowercase Latin characters. We need to partition it into substrings such that each of them is not a palindrome. Should we find any way which does it? Yes, any. Well, this is easy. I think I saw this problem. So to split this string into several without palindromes, what do we need to do? Okay, let's find some stupid solution. So first of all, what do we do? Let's take an element, then take a lot of elements until we first see an element which is not A. This is B. Then we just take it and we continue. So we can do it if we can almost always do it, but unfortunately sometimes bad things happen. And we see a lot of A's, but no B here. So maybe we want in this case to merge this string with the previous one. And when can we do it? First of all, we can do it. So if there is no such string, then we return no. So assume that there is this string. So if this character and this character are different, then we can do it. And if the number of these characters is different from these characters, we can also do it. So the problem is if we have here something like A2, A2, A2. Then we need to merge this with the previous one. Or do we? Do we actually need? So, by itself, this string is bad. By itself, we cannot split it without the help of the previous string. So let's look at the previous string. So again, if this character is different from this one, then we can merge them. So what do we have? We have here, and also, definitely, if this character is not same as this character, we can also win. And if the number of these symbols is different from these symbols, we can also win. So the only problem now is we have A, B, A, B, and again A, B. What do we do then? This case, I believe, no, not A here. In this case, I think what we can do is, so first of all, if this is A, B, A, B, A, then this is kind of bad. Well, actually, if the whole string is A, B, A, B, A, so if the number of A's is not one, then we can split it somehow like this, and we win. So unfortunately, in the end, it is just A, B, A, B, A. So we can go on. And find the first moment when something of this is not true. Yeah, because if we never find it, then we lose. So first of all, if it starts with B, then we lose, definitely. Because we cannot split this. We need to split this into several non-palindromes. Yeah, we cannot, because we will have to take the odd one, and the odd one is definitely losing one. Okay. So at some moment we either find here A, and we can take this, or we find BB and we can take this, or we find something like C and we can also take this. So how can I implement this? Okay, let's implement it somehow. I don't want to spend time, as I said. So TS so we need to split it. So what do we do? We say yes, ans equals find ans s. If ans is empty, print no, else print yes, ans.size, and for int ans0 I less than ans.size for time, print ans I. Yes. Okay, find ans. Let's go. So first of all, if s equals string what do I want to say? First of all, if s0, if s equals string of s of n and s0, then we return false. If s dot front is not s dot back, we return just s. If let's make some procedure. So what do we do? If yes ans, so for int I0 I is less than so ans of size 1, I think. So what do we do? Let's look. So if ans.back, actually I think for char c from s. So if ans.back.empty, we need to just push back to it. Push back c. Also, if ans.back.front is equal to ans.back.back is not equal to it. Then we need to firstly push back nothing, and then we need to push back C here. Yes. Okay. If we do this, then ans.back is not is definitely not empty. Actually, so if ans.back, okay, let's while ans.back is empty, ans.pop back. If ans is empty, turn ans. However, this should be impossible. So if ans.back dot dot what? If ans.back dot dot front is not equal to ans.back dot back, then we return. What do we return? If front is not equal to back, we return ans. Else we need to fix it, because in the end it has repeating symbols. So how do we do it? So let's try something. Let's try something. What do we need to try? So if ans.size equals 1, return nothing. Then we need to try to merge the last two elements. So if ans.r_begin zero dot size plus 1 equals ans.r is not equal to ans.r begin 1 dot size, or they are equal but their symbols are different. So if the symbols are different, then we need to try the following. ans.r begin 1 plus equals ans.r begin 0, ans.pop back, return ans. Okay, now we have the problem. The problem is that we have AAA, BAAA, something like this. Then we need to check, so if ans.size equals 2, then we return nothing. Then ans.size is at least 3. Then let's check again. So if ans. So what do I do? What do I do? I need to check that if ans.r begin 2 is not ans.r begin 1, then I need to say that ans.r begin 1 plus equals ans.r begin 2 plus equals ans.r begin 1, then 0, then ans.popback, ans.popback, return ans. What next? Now, if ans.back dot size is not 1, then we can try the following thing. So we have something like AA, B, AA, B, AA. Then we can split it here. So we can say that ans.r begin 2 plus equals ans.r begin 0. So we have this now. Then we need to remove one symbol. So ans.r begin 2 dot pop back. Now we need to make here. So now we have here the string AAB, for example AAAB, and we want to get A, B, AAAA. In order to do that, we need to push back A and reverse. So ans.r begin 1 dot push back ans.r begin 1 0, reverse ans.r begin 1.begin, ans.r begin 1.end. And then we need to ans.pop back and return ans. Okay, now we have the following problem. So we have A, and then we have AB. Then we have again AB. And we have again AB. So we need to find the first one, which is not AB. Let's try and do that. So for int I is 0, I is less than ans, actually 1. So size. So if ans dot r begin index is not equal to ans dot r begin 1, then break. So if index is at least ans dot size, we have to return impossible. Otherwise, we need to merge everything starting with index. So for int I is index minus 1, I is at least 0 minus I, ans.r begin index plus equals ans.r begin I. Then we need to say that the same number of times we just ans.pop back, then return ans. This is hard to test, but we will try our best. So let's start with this. Okay. So first of all, let's look at this string. Let's look at this string, and let's look at this string, for example. Okay, here it kind of works, yes. So let's look now at this test. So A, B, 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 C, 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 D, 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 A. And then we have something like this, for example. Okay, in this case, it's merged with this one. Okay, but what if we have this? Yeah, in this case, this merged like this. And finally, let's look at B. Did it work in this case? I think actually it doesn't work. Ah. Okay, this is really bad. They said that this is ABA, which is not true. This is not correct. Okay, let's put this in the beginning. So let's look at the answer. Answer seems correct. Index is 1. Once our begin index is not equal to how did it break? I don't understand. Ah, because it is a int index, okay. Okay, it just merged everything into a single string. This should be kind of fine. I hope. But maybe not. What's wrong with Ormless? Is he tired or what? Yes, something's wrong with Ormless. Okay, now we have solved A, B, C, D, E. We need to solve something else. So these two problems are opened by some people. So this is in 19 minutes. So I think both of them might be good for me. I need to carefully choose one of them. So we have a permutation of size n as well as a negative integer k. We need to construct a permutation q of size n such that what is plus? The inf is the number of inversions. So inversion of q plus inversion of q times p is equal to k, or determine if it is impossible to do so. Okay, the standard way is as follows. We say that we have two situations. In one of them, this is at most k, and in the other, it is at least k. This is called discrete continuity. So I think we need to check q equals id and q equals inverse id, because they feature the minimum and maximum possible number of inversions. Okay, after we've done this, we need to make a path. Also, k should be even, of course, because number of inversions. No, k should not be even. K should be of the same parity as the number of inversions in P. Okay. if we have checked that, now we only need to make a path in which each time the number of inversions in Q and the number of inversions in Q times P changes by at most 1. So how do we do this? I don't know. I sincerely don't know. So let's try and see. So we have inversions of Q plus inversions of Q times P. So again, what is Q times P? Q times P is the inversion where Wi is QPI. Yeah, so what can we do in our function? We can swap two what we can do is we can swap two values of Q which are adjacent. So we can swap two values in inverse permutation. We can swap two adjacent values in inverse permutation Q. So this is what we can do. Because this also inverses two values here. Yes? So if we swap two values adjacent in the inverse permutation Q, this results in the following. Here, if we have domain and image, yeah, we swap two elements here. This means that's two neighboring elements here. This means that it cannot change by more than one. When we do it here, we also swap it by at most one. So actually what I would like to see here is some parameterization. So there is some root from Q equals nothing to Q equals ID. Okay, I see, we can do it. Oh, but this is going to be buggy. But what can we do? Okay, so we need to read N and K. So then we need to read P. We need to Q equals find ans of what? Q is find ans of what? Q is find ans of what? Q is find ans of let me think, of P and K. So if Q is empty, return Q is empty, then return, then not return, but then print no. Else we print yes, then we print the permutation. Great, so let's find ans. In find ans we have here vi, and here we also have vi p const ll k. So we need an oracle which finds the number of inversions. Let's make this oracle ll number of inversions. To do it, we need to make merge sort. So what do? We say that we have p.size, we make vi q of size n, we make number of inversions recursive for p q from 0 to n. Okay, well, number of inversions recursive vi p vi q int l int r. So if l is at most, if r is at most l plus 1, return 0. Int m is equal to l plus r over 2, ll equals no I recursive pq l m plus no I recursive pq m r. Then we need to merge them. So we say int I equals L, J equals M, K equals L. Then we can do like this: for int K equals L, K is less than R plus K. So first of all we try to take the pi. So if j equals m, or I is not equal to, if j equals r, or I is not equal to m, and pi is less than pj, then we use pi. So q k plus plus equals p I plus plus, else q k plus plus equals p j plus plus. And then we need to copy q dot begin plus l, q dot begin plus r, p dot begin plus l. But we also need to calculate the number of permutations, and it is simply done here. So we also need to say that answer plus equals j minus n, and return answer. Okay, find the answer. Let's do it. So first of all, we need to find the number of permutations, a number of inversions in P. And if L0%2 is not equal to K%2, we immediately return false, return nothing. If L0 is already greater than K, we also return nothing. Then let's say that L1 is... So what do I want to say? I want to take... Let's make some sort of oracle. So we need to say LL oracle equals const vi q. What does this oracle do? This oracle needs to find the product. So LL x equals number of inversions in Q. Is it okay actually? 2 seconds should be fine, maybe. Okay, I think it should be fine, yes. However, maybe we need to... Yeah, I think... I don't like it. I think we need to have some fixed... I think we need some fixed arrays here, okay? So let's make vi like this, vi like this. Let's make this static. Vi q, if q is empty, q dot resize n. Okay, yes, this should be fine. Not if q dot size does not equal n, we need to resize. Okay, maybe less than n. Yeah, okay. Okay, so what does the oracle do? So we make vi. Actually, I want to have q and w. Q of size n and w also of size n. And this is simply is taking this q. So first of all, finding the number of inversions in q. Then we want to find the product. So how do we find the product? So vi is qpi. So we go vi is qpi. Well, then we need to LLY is number of inversions in W. So return at plus y. So this is the oracle. Okay, LL. So I need to fill Q with reverse permutation. Yes, so UI is n minus I minus 1. So then I say LLL1 is oracle of, actually, if L0 equals k, let's return if L0 equals k, I return q. Then let's find the oracle, and if L1 is less than k, return nothing. If L1 equals k, then I'll do this and return what? Return return q. Okay, now we definitely know that L0 is less than k and L1 is greater than k. So we need some binary search. Let's make some binary search. So first of all, we will make binary search by the number of inversions in inverse q. Okay, so we have inverse q. Let's actually make inverse q So let's make auto prepare. So how do we prepare? We need to have exactly V inversions. So let's make exactly V inversions. So initially we have 0, 1, 2, etc. and minus 1. So if we need to have one inversion, let's just swap these two elements. So we have now n minus 1 and minus 2. Then if we need two more, we swap n minus 3 with n minus 2 and then n minus 1 and minus 2. If we need then 3 more, we also swap n minus 4 with these 3. At some moment we need k more inversions, but we can make I more inversions, but we only can make k more inversions. In this case, so what does it mean? That we can add I inversions. So we have 0, 1, 2, etc. n minus 1, etc. n minus I. And here we have n minus I minus 1. And we need k more inversions. This means that we need to move these k positions to the right. So we have something like this. 0, 1, 2, etc. n minus I minus 2. n minus 1, n minus 2, etc. n minus k. n minus I minus 1, n minus k minus 1, etc. n minus I. So this is our array which we need. So let's make this function prepare. Int I for I equals 0, I is less than n plus I. So what do we do here? We say that if we want, we can add I, or I equals 1. So we can add I more inversions. So if V is at least I, then V minus equals I. Else break. So at this moment, we could add I more inversions, but we only needed k more inversions. So we just need to make this array. This should be easier. So how do we do it? We say inv q. So for int I from 0 to n minus I minus 1. Actually, no, j. We say that q inv q j equals j. Then we have inverse array. We need v elements of inverse. For int j from 0 to v, the qj plus this is n minus 1 minus j. Then we need n minus I minus 1. So we say that does n minus I minus 1 always exist? It seems so, or no? Maybe it does not exist. Yes, it sometimes does not exist. Okay, this is fine. So at the next position, so we say IQ this plus this equals n minus I minus 1. And then we need to push the rest of the elements. So starting with V and ending with I. We push here, but this time remove 1. So in the end, it will be exactly. J will be exactly I minus 1. So this will be n minus 1. And this will be n minus j, n minus I, as needed. Then we need to put in reverse permutation in Q. So we say Q I equals I. So this is a function prepare. How do we do then? So we need to say LL. So LL x equals 0. This is definitely not enough. Y equals n times n minus 1 over 2. This is definitely too much. While true, I think we say LLM equals x plus y over 2. We say prepare n, and if oracle, so then we say LL current ans equals oracle, and if current ans is greater than k, then we say that y is m, else if stans is less than k, then x equals m, else prepare n, return q. Wow. I think that's it. Please work. Solve test, local function. I think I bugged somewhere with this. Lambdas or something. No. Why so many no's? Let's see. So in the first case we have 1 to 0. L0 is the number of inversions of P. This is bad. I see why this is bad. Let's make IQ, let's make W equals P, I think. We find the number of inversions in W. Still everything is bad. So W is, it actually, the sort is incorrect. I don't need to make this. Yes, 2, 3, 1. Yes, 2, 3, 1. I really don't understand anything. So let's look. We have 2, 3, 1, which is P. And we have Q, which is also 2, 3, 1. And we return. So again, what do I want? I want to say that wi is qpi. So p first is 2. So I say q2, which is 3. P second is 3, so I take q third, which is 1. Finally, p3 is 1, so q1 is 2. So I have 3, 1, 2 and 2, 3, 1 and 2, 3, 1, yeah. So the number of inversions here is 2, and the number of inversions here is also 2. However, I don't understand why 3 to 1 also works here, but I said that this doesn't work. So I need to jump maybe here. So L1 is Oracle. So my Oracle is not... My Oracle is not correct. My Oracle is not correct because when I do this, it stops working. So I need something like this. And this way it can work. Okay, 3 to 1, no, no, yes, 15987, 6432, yes, 1. Okay, I even think we can try and submit it. It's funny if this is not TL, because this means that I'm still able to write some good old code. Wow, this is actually not good. This is slow. Let's just hope that this doesn't TL. Hope is a good thing. Do people also get it fast? No, actually my solution is pretty slow. Yeah, for example, Radiwhoosh sped it up 2 times. And maybe I also need to do it. Or maybe not. Pi 364? Really? Let's go on. Problem G, I guess, because nobody solved anything but ABCDFG. We have M baskets along a circle from 1 to M in clockwise order. I forgot to call him for a duel, unfortunately. There are N balls. Ball I is initially placed in basket AI. No basket contains more than 1 ball. Alice is allowed to perform the following operation. Okay, do I need to speed this up? My solution is pretty slow. It has some serious chances of not getting accepted because, you know, this is unstable. My solution is not stable, and Codeforces is not stable. The only advantage is that it takes surprisingly a little memory. I don't know. Let's solve problem G, I guess. will have to be risky. Alice is allowed to perform the following operation, which always takes exactly 1 second. Alice chooses an integer between 1 and n, uniformly at random. If ball I was thrown away before, do nothing. Otherwise, ball I is moved from the basket currently containing it to the next basket in the clockwise order. If the target basket currently contains another ball J, throw ball J away. She repeats this operation until there is exactly 1 ball left. Calculate the expected time needed in seconds for Alice to end the process. Bleh. T from at most 10 to the 4. Okay, yes. Huge numbers, huge numbers. Oh my god, definitely. So Alice takes a random ball and moves it to the next basket. Actually, we can just say that these 2 balls glue up, and that's it. Ah, if ball I was thrown away before, do nothing, so this slows down the process, doesn't it? Okay, we take a ball. Well, actually, what we can say is that we have some partition of M into several addends. And each second the following thing happens. We either do nothing, or we take some addend from the partition, subtract 1 from it, and add 1 to the next one. Yes? Yes. So during this process, if the addend becomes 0, we just remove it and continue everything. So we want to find the expected time needed to end the process. Okay, I think we will have to start with 2 addends. So if we have 2 addends, A1 and A2, and we take at random one of these 2 addends, add 1 to it, and subtract 1 from the other. So how much time does it take? It takes something like, I believe, A1, A2, A1, A2, simply A1, A2. So it takes this much time. So, well, this is a problem because it depends on A1 and A2 a lot. So for example, if we have A1, A2, A3, Oh, maybe the formula just a1 times a2 times a3. Can it be that this is just this simple formula, a1, a2, a3? Can it be? Bless RNG, can it be? Well, first of all, this is actually not a1, a2, because we also need, it's like, we have n balls, and we need to choose one of these two. And the probability of this to happen is 2 over n, so actually we have this multiplicand. Okay, so let's assume that I have a conjecture that the answer is a1, a2, a3 here, times some constant. So we only need to find out this constant. So function for a1, a2, a3, let's assume that all they are positive. They are all positive. Let's assume that they are all positive. How much time do I need to spend? Then, first of all, it's n over 3 times... No, it's not n over 3 times something. So first of all, I spend n over 3 time to just do something, to just make one move. And then one move is either a1 plus 1. Ah, they are cyclic. I'm not sure that this will work like this. Maybe it's some sort of cyclic sum. Maybe it's some sort of cyclic sum. Hammer never fails to impress me. So with probability 1/3 this is this thing, with probability 1/3 this is this thing. And with probability 1/3 this is this thing. And I suppose that here the answer is a1, a2, a3. Can it be? Actually, it cannot. Because the formula cannot be like this. It should be something else. Okay, another hypothesis is that like this is some cyclic sum of something. So let's assume that this is a1, a2 plus a2, a3 plus a3, a1. And here we have no, I also don't believe in this. This cannot be true, because if all a's are small, then this is also, it also seems small, but it shouldn't be so small. Okay, maybe this is just pairwise sum of all a's. So sum of all ai, aj. Let's consider this. conjecture. So n over so like again, this is a1, a2, a3 definitely. So n over 3 plus, with probability 1/3, we get a1 minus 1, a2 plus 1, plus 1 and minus 1, plus a2 minus 1, a3, plus a3, a1 plus 1, plus 1/3 of a1, a2 plus 1, plus a2 plus 1, a3 minus 1, and a3 minus 1, a1. Finally, plus 1/3 of a1 minus 1, a2, plus a2 okay, let's write a constant. So we have a constant here and we have a constant here. So plus a2, a3 plus 1, plus a3 minus 1, a plus 1, a1 minus 1. So what is written here? We have here n over 3 times plus k times what? K actually over 3 also. So this is, no, not over 3. So first of all, a1, a2, there is a1, a2 3 times. So a1, a2 plus a2, a3 plus a1, a3. Then we also have minus a1 so let's calculate for a1. So here we have minus a1, here we have plus a1 and minus a1, and here we have again plus a1. So a1's balanced out, a2 and a3 will also balance. So let's calculate their constant. So here we have minus 1, here we also have minus 1, and here we also have minus 1. So minus 1, minus 3 times 1/3 is minus 1. So k equals n over 3. Yes? Yes. Yes. Yes, 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 yes. Incredible. Okay, let's find the... Also, I want... Are we sure about that? I also want the answer to be consistent with the case when one of i's is 0. Okay, I want the consistency with the case when one of the i's is 0. And this will be hard. Yeah, this will be hard. Okay, so for example, F11A. So by my conjecture, this is one plus a times n over 3. Okay, however, yeah, there are some cases. So it can become, so first of all, I spend n over 3 time, and I get either n over 3, n over 2 times a plus 1, plus, again, n over 2, a plus 1, or maybe no, I wasn't right. So 1, 1a doesn't work like this. So the probability 1/3, this gets +1 and this gets -1. So yes, this. But with probability 1/3, this gets +1 and this gets -1. So we get a and 2, which give us 2a. Finally, we can get +1 here and -1 here, so we get n over 3 times, so we have 1, 2 and a minus 1. So we get 2 plus 3 a minus 1. Let's count this. So what do we have here? We have here n over 3 plus n over 2 times 3a plus 1 plus n over 3, 3a minus 1. Okay, what is it? N times 1/3 plus 3a over 2 plus 1/2 plus a minus 1/3. Okay, this destroys, annihilates. So this is n times 5 seconds a plus 1/2, which is not what I wanted, I think. Or is it? Oh, I expected this formula, which is something else. Okay, I need to somehow find this formula because it is sneaky. It's not what I expected. It's not what I expected. So as I said, I know this formula when we have 2 objects, but we have a lot of objects, more than 2. So for 2, the formula is n over 2 ab. This is okay. This is fine. However, now we need the formula for 3 numbers. Okay, the problem is with all of this that it actually should work. Okay, I think I can just calculate it for some numbers. So again, for example, 1, 1, this is definitely, I need to spend n over 2 times, n over 2 times, and it changes to 2, 0. So this is definite. So again, n over 2ab, this is known. Okay, what about 1, 1, 1? This is definitely just gets to 1. So n over 3 plus answer for 2, 1, which is n. So 4/3 of n. 4/3 of, this is 4/3 of n. How is that possible? This is 4/3 of n. What does it mean? I don't know. Okay, 1, 1, 2. Assume that this is x. Then we spend O and n over 3. Then with probability 1/3, we get again x. Then with probability 1/3, we get 2, 2. And then with probability 1/3, we get 1, 3. So we get plus 1/3 times n over 2 times 4 plus 1/3 times n over 2 times 3. Okay, so x equals 1/3 of x plus of what? So n over 3 plus 2n over 3 plus n times 3 seconds over 3. So 2/3 x equals n over 6 times what? So n over 3 is 2 times n over 6. 2n over 3 is 4 times n over 6. This is 3. So 2/3 x equals 9n over 6, which is n times 3 seconds. So x is 9/4 of n. So it was 4/3 and now it's 9/4. I don't believe it. Why? Why? It's 9/4? It's 9/4? I don't understand. So 9/4 n. So with probability, I always take n over 3. Then with probability, with probability 1/3, I still get 9 this. Okay, with probability 1/3, I have to now deal with 2, 2. So this is 4n over 2, which is 2n. Yes. And then with probability 1/3, I need to get 1, 3. So 1 times 3 times n over 2 times 3 times 1/3. So like this. Yes. And this is just n. Yes, 9/4 n. So 1, 1, 1 becomes 4/3 of n, and 1, 1, 2 becomes 9/4 of n. What? Well, actually, it seems like there is this number in the denominator. It sounds plausible, but what is in the numerator? Maybe square of something. Sum minus 1 squared divided by sum. Can it be? If so, I'm afraid to imagine what it looks like in general case. Clever guys, not like me. Let's continue thinking. So we have a lot of time actually. We still can solve this problem, I believe. This is some simple formula. Yeah, we just calculate the distances, and this is some simple formula of these n numbers. Okay? I'm 100% sure there should be something like this. 99 or 98% sure. There should be something. We just need some way to find this out. So what is the recurrence? So assume that we have a1, a2, etc., ak. Yeah, first of all, we spent n over k time to find. So if, first of all, if k equals 0, and then 0, k equals 1, then 0, we spent n over k time on something, plus 1 over k times sum of what? Of f, ai minus 1, and ai minus 1, ai plus 1, and ai plus 1 minus 1. And each of them with probability 1 over k. Okay, after that, I believe we should immediately say that we divide everything by n over k. We divide everything by n over k. We just should do it in this case. So let's say that f is n over k times g. Then we have g of a1, etc., ak equals 1 over k, 1 plus 1 over k times sum of g's. Great. Yeah, so actually, if we divide by n over k, we have here 4, and we have here, so we need to divide by n and multiply by 3. It's 27 fourths. So it's 4, and this is 27 fourths. What can it be? What can it possibly be? we need some different perspective on this. So I need some different point of view. Alternative, unbiased point of view. So, we have this nice recurrence. Very nice. But at the same time, very bad. Actually, so what I want to say here is that I need several functions which behave like this, and then I need to take some of them in such a way that they also satisfy that they also work with, when some of them are zeros, when some of numbers become zeros. So I want some function such that if there is some zero, I can just remove it from this function, and the value does not change. I need some function such that if I have a zero, then I can remove it and the value does not change. And it should be cyclically symmetric. I need a cyclically symmetric function which does not change when I remove a zero. Okay, let's start with something like a1, a2, a plus a2, a3, plus etc. plus an, a1. This is almost okay. Yeah, but unfortunately, if I have some zero, then I don't have a2, a4. Well, I could add all pairwise products, but it sounds weird if I add all pairwise products. Hmm. Okay, I can have something like this, for example, a1 plus a2 times a2 plus a3 plus times plus a2 plus a3 times a3 plus a4, etc. So if I have something like this, then if, for example, a3 becomes 0, this becomes just a2 times a4, and this works well. So I need actually to continue this up to the end. For example, I will have to have a1 plus a2 plus a3 times a2 plus a3 plus a4 plus etc. Well, okay. Assume that we have all of that. Then how many times I have a1 times a2, for example? There are two mechanisms how I can get a1 times a2. Either a1 was here and a2 was here, or vice versa. a1 was here is just the total number of ways to choose something like this. Yeah, a1 is simply the total number of ways. Okay, let's start with a1 squared, I even think. a1 squared. How many times do I have a1 squared? Actually, I should never have a1 squared. I should never have a1 squared. This is incorrect. I shouldn't have a1 squared. Okay, I'll need to think again. What I'm thinking about is, let's just take, so we have numbers a1, a2, etc., an. Let's just look at the process from the perspective a1 and everything else. a1 and everything else. Okay? Just from this perspective. Then with probability n over 2, then with probability n minus 2 over n, nothing happens. Yeah, so if we just look at this like a1 and everything else, then nothing happens. This is still a1, this is still b. With probability 1 over n, it gives 1 to this big number. With probability 1n, this big number gives 1 to a1. So just for these two numbers, the expected time just for these two numbers, the expected time to stop, to either this stops existing or this stop existing. So the expected time is a1 times b times so this an action happens with probability n over 2, so 2 over n, so n over 2. So this is how much time it takes to either for a1 to win or for b to win. Yeah? Well, actually, I think that okay. So I just know that what do I know? Yeah, I know that this action happens for everyone. So for everyone, this action happens. The problem is that the game does not stop. So if A1 won, if A1 wins, then the game stops, yes. The problem is that sometimes B... I need to calculate the probability that... we were the ones who stopped the game. Yeah, so, like... again, somebody won. Okay? Somebody won. So I want to calculate the following. I want to calculate the sum probability that I won times how much does it take to win for I, given that I won. So this is what I want to calculate. Okay? So this should be not hard. Because this is just a game for 2 people. Okay, let's just again take 2 people. So A wins with probability A over A plus B. And B wins with probability B over A plus B. Yes? So if I know that A wins, what is the expected duration of the game if A wins? Oh my god, this shouldn't be hard. Let's calculate it for small numbers, because it seems that like my brain does not work. So 1-1, I know that the expected durations are 1 and 1. Okay, 1-2. Yeah, then so we have X and Y. So X so what I know that, so if I have X and Y here, then X times A over A plus B plus Y times B over A plus B is just AB. So my hypothesis is that X equals B times A plus B. No. X equals AB maybe, and Y also equals AB. So if so, then it makes sense, actually. So if they both are just equal to AB, then this makes sense. However, I don't think so, yeah? For example, if we have 1 and n, then definitely this wins slowly, more slowly than this one. Oh, I need to speed up. Do I need? Well, I can do it slowly, but yeah, I need to speed up, of course. So 1, 2. If I have 1, 2, then what's the probability that 1 wins? 1 wins with probability 1/3, and 2 wins with probability 2/3. Yes? So let's say that this is x and this is y. So what is the expectancy for x? For x, the expectancy is x over 3. So x equals 1 plus... No, actually... So assuming that I know that this wins. Yeah, I know that this wins. This changes everything. So since I know that the left thing wins, this becomes kinda stupid. Okay, let's start with this one. How long does it take for the second one to win? So the probability is 2/3, so I need to just calculate the expected value in all cases when it wins. So it wins in one move, or with probability 1 to 1 second, it happens in one move, or with probability 1 fourth, 1/8, it happens in 3 moves, or with probability 1 over 32, it happens in 5 moves, etc. So it happens in 1 second plus 1/8 plus 1/30 seconds plus etc. plus 2 times 1/8 plus 1/30 second plus 1/108 plus 2 times 1/30 second plus 128 plus etc. plus etc. Okay, what is this? This is 1 second times 1 divided by 1 minus 1 over 4, which is 2/3. Yes, this is 2/3. Okay, so we have 2/3 plus 2 times 1/6 plus 2 times 1/24 plus etc. Okay, so what is this? 2 times 1/6 times 4/3, which is 8/18 times equals 4/9. So 2/3 plus 4/9 is 6/9 plus 4/9, which is 10/9. It doesn't make sense. So I just cannot find this formula even for 2? We need bounded. So again, what do I need? I need to find the probability that not probability that expected value of stopping at L and stopping at L from P equals I. Yeah, where we have like A and B here, equals A. So we can go here or here. But we want to calculate the expected value here. So EAB equals what? So now the probabilities are skewed actually. Let's write what I want from this thing. So if I know that I end up in the left part and that I end up here, what are the probabilities? Actually, they are not 1/2 and 1/2. Yeah? Why is that? Because so probability that I go to the left, given that I end at the left side, equals that the probability that I end at the left, given the left, divided by times the probability that I finish at the left, divided by the probability that I end at the left. Yes? Does it make sense? Yes. So I know everything here. So the probability to end at the left part, given that I will go to the left, is left minus 1 divided by left plus right. So times 1/2 divided by probability to end at the left part, which is L over L plus R. Let's calculate that. This is... So let's multiply both things by 2L plus R. Okay, this is my thing. L minus what? Over 2L? Doesn't sound great. Because I end at L. Okay, whatever. So probability to go left. So I want it to be like this: L minus 1 over 2L, A minus 1 over 2A times E A minus 1 B plus 1 plus A plus 1 over 2A times E A plus 1 B minus 1 and plus probability that I just win. The probability that I just win is A over A plus B. Okay, now I don't have much time. Yeah. Let's simplify this. Let's simplify this fast, actually. Let's simplify this fast. So, let's say that FAB is A plus B times E A B. then FAB is, so I need to multiply all of this by AA plus B. So A minus 1, A 2A plus B, E, and instead of E, I can say that EAB is A plus B over A FAB. So here I can say that it is A plus B over A minus 1 times FA minus 1 B plus 1 plus A plus 1 over 2A plus B times A plus B A plus 1 F A plus 1 B minus 1 plus, so I need now, so F AB is A over A plus B times this. So here I have A squared times over A plus B squared, don't I? Yes. Yes. So FAB equals 1/2 of FA minus 1 B plus 1 plus FA plus 1 B minus 1 plus A squared over A plus B squared. This is my thing. What? So I want some function f of a to be equal f of a plus 1 plus f of a minus 1 over 2 plus a squared over a plus b squared. Okay, what is that? Let's say that 1 over a plus b is some sort of t. Then I want to say that f of a is f of a plus t plus f of a minus t over 2 plus a squared. Yes, so this is something cubic, I think. Oh no, I don't, oh my god, I don't know. I don't know, and I don't like it. Okay, let's say that this is just a cubed. Maybe. Maybe it is just a cubed. So a cubed plus 3a squared t plus 3at squared plus t cubed plus a cubed plus minus 3a squared t plus 3at squared minus t cubed over 2 plus a squared. Yes? Yes, equals a cubed. So this cancels out, also this cancels out, this cancels out, and I am left with 3at squared plus a squared. No, this is bad. This means that I need some fix. Ah, maybe fourth power? Okay, so maybe f of a should be a to the fourth power. So it should be a4 plus 4a cubed t plus 6a cubed t squared plus 4a t cubed plus t fourth plus etc. a fourth minus plus minus plus over 2. So what do we have? We have a to the fourth plus 6a squared t squared plus t to the fourth power. Okay, not much time. Okay, let's say that I want this to be a squared. So this should be a squared. To make this a squared, I need to take divided by 6t squared. So f of a now is a to the fourth power divided by 6t squared. If I do this, then I now, instead of t to the fourth power, have here t squared over 6. So I need somehow to remove t squared over 6. To do that, I need to set... So I added this, but I also need to subtract this. So let's try f of a equals a squared. So this means that I will have a squared plus 2at plus t squared, and then plus a squared minus 2at plus t squared means that I get t squared. So I need to subtract a squared over 6. So my solution is f of a equals a to the fourth power divided by 6t squared minus a squared over 6. This is the formula. This is the expected duration of the game. Oh my god. Let's try to write this. Not the best moment. 14 minutes on this problem. I hate it. I hate it. Don't try to me, please. Yeah, the best moment to do it. N and M. Oh, are you kidding me? So we need to print. Please. Why now? This is not funny. Fine dance. And I need to print it. Okay, so fine dance given vi a and const int m. So what do I do here? I say that we need to sort a. We need to find all the differences between them. So okay, if a dot size +1 return 0, sort, then for int I 0 less than n plus I, bi is difference between a I difference between this a and this a modulo m. So now I need to calculate some function of b. Okay, let's go on. So as I said, this is my formula, 6t squared. So now I need to understand what is t and what is a. Yes? Are you kidding me? Ah, I need to... So again, what is... Let's write it in terms of a and b. So 1 over a plus b is t. And a is actually a over a plus b. So now I have a over a plus b to the power 4 over 6 divided by a plus b to the power minus 2 minus a squared, which is a plus b squared, which is simply simple dimple what? A over a plus b times, so this is a to the 4th divided by a plus b squared. Ah, so this is something like 6a plus b squared, and here I have a squared, and here I have a 4th. So something like this. Okay. So what? So this is f. Yes, this is f. This is f. What E is f times a plus b over E. Oh my god, I don't like it. What does it mean? So what is EAB? EAB is so if I end on the left, this is the answer. If I end on the right, it is 0, okay? Yes. Okay, this is what I need. This is what I need. Okay, so then I need to multiply it by a plus b over a. So now we have a cubed minus a over 6a plus b. Fine, so this is the probability that... this is the expected duration of the game if somebody won. So, okay, let's go... So let's assume that somebody won. That BI won. This means that A should be everything else. So I need to take int A equals M minus BI. Then I need to say that I need to calculate A cubed minus A and divide it by 6a plus b. So in the end, I will divide it by 6a plus b. What? This is painful. Almost, but nothing near that. So now it's a bit better, but no, still no. Okay, this is the expected duration of the game if... Maybe I need to say BI here? I'm not sure. No. I don't understand. Yes, this doesn't make sense because a cube minus a is 0 for a equals 1, which shouldn't be like this. It shouldn't be true that... It shouldn't work like this. But for some reason it says that it is 0. Maybe plus? Maybe it should be plus? No. Don't think so. So again, t is 1 over a plus b, as far as I remember, yeah? Yes. And a is simply a over a plus b. So here I have a over a plus b. Why is it 0 for this number? Maybe I need more another constant. But it doesn't seem like I need another constant. It's so sad. I don't have time to debug this, but the solution is in my hands. It is literally in my hands. Maybe I need to multiply by n over 2. So in the end it will be just 3. No. Almost. Sad. Sad because I was able to find this formula. This wasn't an impossible task. Oh my god, Ormley solved both of them in the end. Well, this was a sad defeat. So I spent 1.5 hours and didn't solve this stupid problem. This is not normal. This is not normal. Oh my god. So let's summarize. This duel is lost. This duel is... Oh, no. This duel is won, of course. This duel was not declared. This duel was won. Here we don't have anything. This duel is lost. This duel is lost. And that's it. I don't see Bochka. Let Bochka participate. Tranquility. So did Tranquility participate? I don't see him. So probably not. Okay. I believe we should upsolve problem G. So let's calmly revisit everything that we have achieved. So we have found this formula, totally incorrect formula. Unfortunately, it is totally incorrect. So let's return back. So I want to find some function of a and b of what? So let's put it that way. So I have a segment from 0 to 1. I start here at, so here we have several dots, t, 2t, 3t, etc. T times 1 over t minus 1 and 1. So one of these points is A. After that, I want to find this function f for each point in such a way that f of a okay, let's first of all take it initially. Initially, I have e of ab equals what? If this is the expected duration of the game between a and b. Yeah, same, but here we have 0, here we have a plus b, here we have a. Given that a will lose, so it goes here. What is the expected duration of such a game? So I calculated that with probability a minus 1 over 2a, this person goes here, and with probability a plus 1 over 2a, this person goes here to the right, or not. Actually, maybe no. Yes, I totally misunderstood everything. Yes, it should be something else. So, with probability a over a plus b, a loses. Oh, actually, b over a plus b, a loses. Yeah, my formula was wrong. Unfortunately, my formula was wrong. So if I did it correctly, and if I did it fast, it would be okay. So with probability b over a plus b, a loses. Okay. Let's assume that b loses. That a loses. Let's assume that a loses. Then with probability, then first of all, they spend one move. Then with probability a minus 1 over 2a, they go to the left. No, let's revisit everything. So again, probability a loses. No, a goes left given that a loses equals probability that a loses given that a goes to the left times probability that a goes to the left divided by probability that a loses. Let's calculate that. So probability that a loses given that a goes to the left is b plus 1 over a plus b. What is the probability that a goes to the left? A priori, this is 1 over 2. b that a loses is b over a plus b. So we get b plus 1 over 2b. So here we have b plus 1 over 2b times e a minus 1b plus 1 plus b minus 1 over 2b e a plus 1 b minus 1. Okay. we simply say that, of course, we need to look at FAB equals A plus B over B EAB, and EAB is B over A plus B FAB. Then FAB by this recursive formula is B over A plus B times 1 plus something plus B plus 1 over 2B times no, I wasn't correct. FA plus B is A plus B over B EAB equals A plus B over B times, and this time we have B over A plus B, times 1 plus B plus 1 over 2B times EA minus 1 B plus 1. Actually, I can still get failed system testing, and then we can end our programming career. Because this is not funny. Times E of A minus 1 B plus 1, which is what? E of A minus 1 B plus 1, which is I don't like it. I don't like it. This is not good. Why did it work last time? Last time I kinda did the same thing, but it worked. Didn't it? Why did it work? It worked because I did everything incorrectly. Okay. Do I actually do it correctly this time? Again, so let's say that EAB is conditional expected value. Again, so it is 0 if A wins, and this is B over A plus B. Okay, so let's simplify it. So I don't want to hurry in this case. So what do we see actually? We actually see the following. We actually see that EAB is BA plus B plus B plus something over 2. What is over 2? B plus 1 over A plus B times EA minus 1 B plus 1 plus B minus 1 over A plus B of EA plus 1 B minus 1. This is what we need to calculate. Well, what can we do with this BA plus B? Actually, we can put it inside this E. We can say that this is 1 plus thing. And we can say that this is 1 plus thing. Yeah, this makes sense. This actually makes sense. And after we've done it, I think we need to say that we want f of A and B to be equal to E of A and B times B over A plus B. So f of A and B is equal to b over a plus b times, so here we have b plus 1 over a plus b plus f a minus 1 b plus 1 plus b minus 1 over a plus b plus f of a minus 1 b plus 1, a plus 1 b minus 1. Nice. So when we simplify it, we get that f of a and b becomes f of a minus 1 b plus 1 plus f of a plus 1 b minus 1 over 2 plus, so this is simply b of 2b over a plus b, so this becomes b squared over a plus b squared. But no, because I have here b over a plus b. This is the difference. I have here b over a plus b. And this is strange. Yeah, this is strange. Why do we have b over a plus b here? Does it mean that we need some factorials to get rid of it? I don't think so. I don't want any factorials here. I don't want to see any factorials here. So the next logical step that we need to take is what? Is to say that we want to take b equals b over a plus b. And let's say that instead of fab we get something like, so let's say that c is a plus b, so now we have function fc of b, which is fc of b plus, so also let's say that t is 1 over a plus b. So we have something like this times b plus b squared. Okay, the first step that we need to take is to get rid of b squared. To do that, let's say that one of like addends in this thing is b squared. No, actually just b. So let's say that gc of b is actually it seems like I need kb cubed plus no, let's say that fc of b equals kb cubed plus gc of b. Okay, let's write it like this. So I know that it is kb plus t cubed plus kb minus t cubed plus gc of b plus t plus gc of b minus t over 2 times b plus b squared. Okay, so this is just gcb plus t plus gcb minus t over 2 times b plus, now let's work with these two things. So first of all, this is, oh my god, it is bad, it is really bad. Oh my god, we have huge problems. You know, we have huge problems. Actually, this seems awful. Actually, I need some powers of some characteristic polynomial, don't I? I do need some. Oh. Why? Oh, so why when I ask for the duration of the game, it is easy. But when I ask the duration of the game, given that it is finished by the first player, it becomes really hard. Am I doing something wrong? At least nothing failed system tests. Okay, at this moment, contest goes nice. After that, some people solve some hard problems. Okay, so actually, what I need here is not a polynomial. It will be an exponential thing. So actually, to get here b squared, I simply need to add a constant. Without any b cubed. Ah, no, I need b cubed. Ah, I need b cubed. Yeah, this thing depends on... So, it seems like I need to add b. So, gc. So, first of all, we need to get rid of this. I think that I just need to say that fc of b equals b Combinatorics, math probabilities. Who would think? Who would expect such topics in this problem? I don't like my approach. I think it is a disaster. Maybe we need to somehow find another way. I think we might need to find some other way. So again, so we are here. We are maybe this is because my formula is again incorrect. I think it is incorrect. Yes, it is incorrect. So let's do it much more accurately. Much more accurately. Much more accurately. So let's consider all possible roots, and each of them is multiplied by 0 if it ended here, and it is multiplied by its probability if it ended here, and we sum them up. So this is a huge sum. Now I want to find this sum for A. Okay? How does it look like? First of all, let's look at the first step. The first step was made with probability B over A plus B. Then I either stepped here with probability B plus 1 over 2B, or here. If I stepped here, then I need to consider all possible roots. I still consider all possible roots starting here. And I just need this beautiful sum, which is A minus 1B plus 1 plus B minus 1 over 2B a plus 1, b minus 1. Okay. Actually, I took much more time than I expected and much more than there is in the contest. Okay. After that, we actually can make the change that I was talking about. Namely, we can say that f AB is EAB times b over a plus b. So then I can say that it is b squared over a plus b squared plus, so then I need to multiply this thing by b over a plus b, which is b plus 1 times 2 a plus b times this e. However, if we again remember this formula, we see that e times b over a plus b is f. So instead of that, I can say that this is just 1/2 of f a minus 1 b plus 1 plus 1/2 f a plus 1 b minus 1. I feel somewhat stupid because this is what I already saw earlier. Let's go on. Now I want to get rid of this addend. To get rid of this addend, I need to say that let's again make the same thing that I did before. Let's say that x equals b over a plus b and t equals 1 over a plus b. Now I have ftx equals x squared plus ftx plus t plus ftx minus t over 2. Then I say that I want to express ft of x as kx to the 4th power plus lx to the 2nd power. Let's see what I expect here. Kx4 plus lx squared equals kx squared plus, now we have sum of two 4th powers and 2 2nd powers. 2 kx 4th plus 12 k x squared t squared plus 2 k t 4th plus 2 l x squared plus 2 l t squared over 2. This is equal to x to the 4th power times so here we have 2k plus 2k plus x to the 2nd power times 1 plus 6kt squared plus L and plus constant k t to the fourth plus L t to the second. Okay. Okay, actually this is not true. Okay. So we have three qualities. This is automatic. This is not automatic, but I have 1 plus 6k t squared equals 0. So k equals minus 1 over 6t squared. Finally, this should be 0. So I know that kt for to the fourth power plus lt to the second power equals 0. So L equals minus k over t squared, which is 1 over 6t to the fourth power. Yes? Or no? No! What am I writing? What am I writing? Oh my god, I am totally unable to make any math. Minus kt squared here should be. So this is 1/6. So actually my final formula is k minus 1/6t squared x to the fourth power minus, again minus, what? No, I don't understand. How can it? Why is it negative? Ah, because I need to add some constant afterwards. Yeah, if I add a constant, it is always stable. So I just need to add a constant such that it becomes the solution. So x fourth to 60 minus x fourth times divided by 60 squared minus x squared over 6 and plus constant. This is my formula. Let's go back to A and B. So f of a b is c minus, so x is a over a plus b. T squared is, so here we have a plus b squared minus a squared a plus b squared times 6. Good. So c equals c minus, now let's write this as a denominator. This is b, not a, times 6. Actually, this is plus. This should be plus. Because here it is plus. Here it should be plus. Oh my god. So this is b to the fourth power. So plus b squared. Oh, okay, minus. Minus is better. B to the fourth power minus b squared. This is my formula for f. Now we need to find the formula for e, and e is f times a plus b over b. Okay, this is our formula. So, again, if I have this segment and I want A to lose, the left player to lose, it takes this much time. Where C is some constant. How to find this constant? We need to find some value of B for which we know the answer. Okay, for which value of B we know the answer? When B equals A plus B. So when A equals 0, we know the value of this constant. Yes? When A equals 0, let's write it. E0s equals s over s times c minus s cubed minus s divided by 6s, which is equal to c minus s squared minus 1 over 6. And we know that in this particular case, A always loses. So the expected time to lose should be 0. So C equals S squared minus 1 over 6. It seems so. In total we have the following formula. A plus B cubed minus A plus B minus B cubed minus B. Or, so A plus B cubed minus B cubed minus A. Divided by 6A plus B. Let's make some sanity check. So sanity check is, we say that if we add, so we want to get AB if we add the second counterpart, which is A plus B cubed minus A cubed minus B over 6 A plus B. So what do we get here? Here we get 2A plus B cubed minus B cubed minus A cubed minus A minus B. Good. Or not? It seems strange that we have minus a and minus b here. They seem alien. A bit of an alien. Of course, again, my formula are incorrect because I needed... So I need to take a plus b over b and multiply it by c. I took this c and I never multiply it by s over b. Yes? Let's fix that. I need to multiply c by s over b. Minus b cubed minus b over 6s. Incredible. So in total it becomes 6bs. So we need to multiply this by s and this by b. So s fourth minus s second minus b fourth plus b second. Again, let's make a sanity check. I want to say that if I add two of these things, I get ab over 2. Which I really doubt at the moment. So a plus b fourth to the fourth 2 times minus 2 times a plus b squared minus a fourth minus b fourth minus... It's definitely incorrect. It's definitely incorrect. Oh my god. Oh my god, I hate this. I hate this. This is bad. Well, there should be a reason why people solve this in 20 minutes. There should be some method. Geothermal solved it in 16 minutes. My method is I cannot solve this problem so fast with my method. It should be possible. It should be somehow possible. Why the expressions don't match? I really don't understand why they don't match. they don't match at all. Yeah, they don't match. So when A is small, it should be something like AB. Okay? When A is small, it should be something like AB. Let's assume that A is very small and B is very big. Then it should be something like AB. Because the first element is something like 1 and everything else is something like 1/2. It should be something like AB. Okay, now it should be. It seems really weird. Yes, it's really weird. Not bad. I'm disappointed. But let's agree that it is kinda okay. Still no editorial. Ah, we can find the editorial. What is G? Okay, this makes more sense. His solution is same as mine, but he wrote the formula correct and I did not. This is exhausting. Okay, my formula is incorrect, I think. You see? He has a 1 here and I have b over a plus b here. Why is that? Because I again was unable to use the conditional probabilities correctly. Let's try again. Okay, I live here. So, okay, let's consider the case when let's consider the case when we end up here. So let's stick to this case. Let's say that EAB is the expectation conditionally that we lose. In this case, we always make one step, and then with probability 2b, b plus 1 over 2b, we go to the left and have the same conditional expectation there. Or to the right and have the same conditional expectation there. Good. And what? And what? Ah. So maybe the problem was that when I wrote, so here I had didn't have any conditional expectation. So it is just a regular expectation, but with custom mass function. So I say that if I end here, it results in 0. If I just have no conditionals, but I have a custom mass function, then these probabilities should not be conditional. They should be regular probabilities. This is my error. I shouldn't have used any conditional probabilities here. Okay, let's try to continue doing it my way. Without conditional probabilities, without regular probabilities, without regular expectations. So the expectation is A over A plus B, B over A plus B. Then, with probability 1/2, I always go to the left, and with probability 1/2, I always go to the right. So this is just E A minus 1 B plus 1 plus E A plus 1 B minus 1 over 2. Oh my God. So let's simplify this the 5th time, I don't know. Okay, this time this is already in the good shape. This is how I want it to be, because I don't have any coefficients. The only thing that I need is to get rid of this constant. To get rid of this constant, I need something like what? Okay, let's again introduce some function. So let's say that x equals b over a plus b. Let's say that t is equal to 1 over a plus b. Then let's also say that e t of x is simply e of ab. Then this is equal to x plus et of x minus t plus et of x plus t over 2. So I need to somehow find a function which emits this x here. This is just some square function. No, this is some linear function, actually. So I want to say that et of x is kx plus l. So I want it to be x plus kx minus kt plus l plus e plus kx plus kt plus l over 2 equal to x times 1 plus k. It sounds horrible. It sounds pretty much really horrible. Ah. So I want to get x here. How do I get x? How do I get an x? Okay, so linear function would not work, but maybe the quadratic function also does not work, because I get x squared plus t. So I need a cubic function. Again, I don't like it, but it seems like I need a cubic function. let's write a cubic function. So okay, it should be k x cubed plus lx plus n. Okay, so it is equal to x plus kx cubed minus 3k squared t x squared t plus 3kxt squared minus kt cubed plus kx cubed plus 3kx squared plus 3kxt squared plus kt cubed. Okay, then lx plus lx minus lt plus lx plus lt. Over 2. So what do we have here? So x cubed is only here and here. So in total we get a kx cubed. So what about k squared? So we have 3kt minus 3kt here plus 3kt squared here. Ah, no. Plus 3kt here. In total 0. Okay, then x. So we have 3kt squared. And again 3kt squared here. Also plus 1 because of this x. And plus L because of this. Finally plus LT plus LT. No, it shouldn't be plus LT. Yeah, it's not plus LT because here we have minus LT, here we have plus LT, here we have minus KT cubed, here we have plus KT cubed. So also plus M and plus M, so just plus M. Okay, so this is equal to this is fine. This is equal to this is fine. So the only thing that we have is that k equals minus 1 over 3 t squared. So our function et of x equals minus x cubed over 3t squared. So e of x and y equals minus b cubed over a plus b cubed times 1 over 3t squared, which is a plus b squared over 3. This results in b cubed minus b cubed over 3a plus b. This is the expectation given that, not the expectation, like the conditional expectation times the probability. That's it. Yes? Or no? Maybe. Maybe. So again, let's combine this up. So I have AI and I have the rest of the AIs. So I want to calculate the probability. So I want the expected value of AI winning. So I want all cases where AI won, and I want the expected value there. Then this means that this person should, which is like BI, this person should lose. And if I want to calculate the probability, the expectation of it losing, it should be something like, so each move takes n/2 time, and oh no, this is not correct. This is not correct because I also have unknown LX. Yeah, I also have here plus LX plus M. Yeah? Which is L... What is X? X is B over A plus B. So this is my formula. I don't know L and M, but I know this. So I need to somehow find L and M. Okay, let's make some observations here. So I want if A equals 0 to get 0, because when A equals 0, I already lost and I don't need to proceed. So when A equals 0, it should be 0. However, now it is minus B squared over 3 plus L plus M. So L plus M is I squared over 3. Okay, when B equals 0, I also want 0. So this means that M equals 0. So this means that L is S squared over 3. So in total I get EAB equals, so let's substitute it here. So L is S squared over 3. So A plus B, B over 3 minus B cubed over 3 A plus B. Let's try to simplify it to make it more lovely. So it's B over 3. Here we have A plus B minus B squared over A plus B. This is equal to B over 3 times this, which is equal to AB times A plus 2B over 3A plus B. now this is at least satisfying the sanity check, because when I swap A and B, I get here B plus 2A. In total, it becomes 3A plus 3B. So it destroys with the denominator and I simply get AB. Finally, we have the nice correct formula. This is the correct formula. And I just need to sum it up, multiply by n over 2. Yeah, so let's do it, maybe. So A should be the one who loses. B is BI. So I need to add to some fraction. Actually, instead of, I want to divide by 3a plus b in the end, so I just need to say take ab times a plus 2b. AB a plus 2b. Okay, in the end, I need to multiply by n over 2 and divide by 3a plus b. So in total, it becomes something like this. Multiply by n, divide by 6a plus b. So let's say int coefficient equals product of n and inverse of product of 6 and n. And ans is the product of ans and coefficient. No. No. Still no, this is not good. Ah, 6m. 6 actually, yeah, m. Well, it means that I didn't deserve the plus. Of course, since I spent how much? Hour and a half on this problem after the end of the contest. This means that my formula needed some more like faster approach and more accurate approach, which I did not have. So congratulations to everyone who had such an approach. Let's go through the problems which I solved, because I didn't explain them much during the contest. I know that like I talk while I am solving this problem, while I'm solving these problems, but especially during problems A, B, and maybe C, I wasn't much talking because I was aiming to solve them fast. Okay, there are n lamps numbered from 1 to n lined up in a row, initially turned off. We can perform the following operation any number of times. Choose 2 non-adjacent lamps that are currently turned off and then turn them on. Determine whether you can reach configuration S, where S is given. This is a really easy problem. To solve them, you need to understand. So, like, what is the approach if you want to solve this problem? First of all, let's understand the answer. Yeah, answer. When can we get this configuration? Sometimes, in some situations, you understand that the answer is yes, you can. In some situations, you can understand that the answer is no. Let's just make a table. Here we say yes, can get. And here we say no, cannot get. Okay. Let's just go. We need to add some situations to the left column or to the right column. Sometimes we understand that. So we see some situation, and either we can put it in the left column or into the right column, or maybe we cannot, because actually this situation is too complex. In this case, you need to divide it, to separate it into several fewer smaller situations and put each of them in a column. So can we put at least something in the left column? Of course we can. For example, if all zeros, then we can put it in the left column. Oh, well, maybe there is something that we cannot put in the left column. And indeed there is. For example, you can see that you always turn on 2 lamps. Let's forget about non-adjacent, but you turn on 2 lamps. This means that always the number of lamps will be even. So actually, if number of ones is odd, is in the right column. If the number of ones is odd, you cannot get this configuration. So all zeros in the left column, odd number of ones is in the right column. Maybe if the number of ones is even, then we always can put it in the left column. Unfortunately, no. If you think about it, you can understand that there is some situation when the number of ones is even, but you still cannot get it. This type of situation is when you have only 2 ones and they are adjacent. Yeah, because you just need to make one operation, but you cannot. So number of ones equals 2, and they adjacent. This is the right column, you cannot get it. However, if the number of ones is 2 and they are not adjacent, then you can get, you can just add them both. So let's write it. Number of ones is equal to 2 and they are not adjacent. So now we're thinking about what happens when there are at least 4 ones. So the number of ones is even, yeah, because odd is here. The number of ones is not 0 and 2, so it is at least 4, because 0s and 2s are already in this table. What can we do then? Actually, we can win. So let's look at all our ones. Notice that actually, since there is an even number of them, for example, m, m. The number of ones is m. Let me write it here. Number of ones is m, and m is an even number. I even better write m is to k. So there are 2k ones. Notice that you can divide them into pairs, which are all non-adjacent. For example, you can take the first one and first plus kth. So first and first plus kth one. They are definitely not adjacent, because here we have other ones. Similarly, this one is not adjacent to this one. So the second one is not adjacent to second plus kth one. Again, because, for example, this one is between them. And so on. Each of these pairs is not adjacent. So actually, if the number of ones is at least 4 and even, then you can always win. So this is the criterion. You only get no if there are 2 adjacent ones or the number of ones is odd. Otherwise, the answer is yes. They also say greedy, but I don't know why. And they also say games, and I even less understand why it is games. It is not a game problem. Battle cows. So there is a quite understandable tournament system. You have an array. Let me translate it from the cows to numbers. So you have some array. It consists of different numbers, pairwise different. Now then you make the following process. You take the first 2 numbers. You take the maximum of them. For example, it was A2, and you give 1 point to this number. You don't add 1 to this number, but you just draw somewhere near it that it gets 1 point. Then you compare this number, the maximum of this prefix, with the next number. If it's still greater than it, then you add 1 more point. Now it's 2. Then you take again the next number and compare it with this prefix maximum. If now A4 is the prefix maximum, now A4 becomes the lord here, and it gets 1 point, and so on. Then the next number again is compared with the prefix maximum, which is A4, and if A4 is bigger, then it gets 1 point, and if A5 is bigger, then it gets the point, and it becomes the main number, and so on. You have number AK, and you want it to get as many points as possible, and during this process you can make at most 1 swap of this number with something else. And the question is, how can you maximize the answer? So this is a nice problem. Let's look at our AK. We wanted to win as many comparisons as possible, so that it is maximum in this comparison. Let me think. So, first of all, some sort of naive consideration maybe, but still, look at your AK. Notice that, can we just leave it as it is? Leave it here. Actually we can, but this is not a very great idea, because there is a strategy which is always better than leaving AK as it is. Namely, notice that if AK minus 1, if this maximum is greater than AK, then you just get 0 points. AK is eliminated immediately and does not get any points. So this is not an interesting case, because if AK gets 0 points, then literally any strategy is not worse. However, let's now look at the case when AK is greater than this maximum. This means that AK is actually greater than all these numbers. But this means that actually we lost a lot of points. We lost a lot of points. Yeah? So there are k-1 numbers. And instead of comparing with each of them, AK only was compared with one of them, which is the maximum. So AK got 1 point instead of k-1 points. Usually k-1 is at least 1. And even when k equals 0, k equals 1. Yeah, so when k equals 1 and this is 0, 1 minus 1, then it is compared with 0 instead of 1 because no comparisons were made to the left of AK. So actually, it is always better to swap AK with the first element than to do nothing. So the first thing that you try to do is to swap AK with the first element and find the answer. Okay, great. Let's look at it. Let's find this answer. And let's ask ourselves, can we do better? So we swapped this number AK with the first element. Can we do better? For that, we need to understand how many points we get for that. And actually, it's quite straightforward to understand. So, to understand that, so let's swap AK and A1, AK, A2, A3, etc. AK minus 1, then A1, then AK plus 1, AK plus 2, etc. Sorry. Let's see how many points we got for that. Actually, the number of points that we got equals the number of elements, the first several elements, which are less than AK. For example, if there are 5 elements in the beginning which are less than AK, excluding A1, but including if this prefix at some moment takes this A1, captures it. So we get the number of elements equal to the number of elements which are less than AK. Actually, this makes sense, because we cannot get points from numbers which are greater than AK. However, what makes no sense is if we stop very early. We stop very early if we stop this prefix at some number which is greater than AK. Yeah? So if we don't touch this number, let's look at the first number which is greater than AK. If we don't touch it, then our answer will not be bigger than the answer that we get when we swap AK and A1. So again, my statement is, let's look at the first element which is greater than AK. If you don't touch it, you cannot get any answer which is better than just swapping AK and A1. Simply because when you swap AK and A1, you get absolutely all elements which are less than AK. There is a tricky case when A1 is that element which is less than AK, but in this case you touched it. So if you don't touch it, you indeed don't get more elements than the number of elements here. Okay, so the only way, if you want to get any more, is to somehow touch element number AK, the first element which is greater than AK. However, the only mechanism you have to touch AK is to swap let's call this number AQ, for example. the only mechanism you have to touch AQ is to swap AQ and AK. So you always also try to do this, to swap them, and sometimes you will get a more optimal answer. If you want an example, I will provide some example. For example, 1, 10, 3, 4, 6, 8, 11, 13. And this is your number. If you just swap it with 1, you don't get any points, simply because this 10 blocks you from all normal numbers. So instead of that, so you get 0 by the basic strategy of swapping with the first element. However, if you swap 8 and 10, it can be better, because now you have 8, 3, 4, 6, 10. Now 8 gets compared with this number 1, with this number 3, 4, and 6. So it wins 4 duels, and it is better than 0. However, it is not always like 0 and something. For example, if I add one more number here, 2, then the basic strategy gets 1 point, and our strategy still gets 4 points. So it might be bigger than this, or it might be smaller than this. All situations are possible. So the easiest thing to do is just check both possibilities. You can check the possibility in linear time, just straightforward implementing this algorithm as it is written. It is again, it's written here that it is a binary search, yet personally I did not use any binary search here. It is just greedy. Or even not greedy, but case consideration. Something like that. Problem C, ticket hoarding. As the CEO of a startup company, you need to buy K tickets. There are n days when you can buy tickets. The price during this day is AI, and you cannot buy more tickets than M during a day. However, if before some day, so if you consider all the time that elapsed before the today day, and during that time you bought, for example, B tickets, then all prices today are increased by M. So here we have an example. Here were the prices. If you buy the first day 2 tickets, all these prices increase by 2, and now we have 5, 10, 6, 7. When you also add 8 more, when you buy 3 more tickets during the second day, this increases by 3 also. So in total it was increased by 5. And you need to find the minimum cost, again greedy. Find the minimum cost of buying K tickets. So what helped me solving this problem is looking at it from the following point of view. Let's say that each ticket, so it was said in the statement that if you buy at some day B tickets, then all the future prices here are increased by B. I will slightly modify my statement. Now I say that if I buy a ticket, it increases by 1 all future purchases. Even the next ticket the same day will be also increased by 1. So I have something, something plus 1, something plus 2, etc. Notice that for these tickets, the impact imposed by these tickets did not change. Yeah, all these tickets gave plus B to these tickets. The only thing that was changed is the costs within the days. Actually, we can say, we can find out how it changed. Yeah, so cost prime equals cost plus sum for all days, the number of tickets that you bought during that day, which is BI, and sum of all numbers from 0 to BI minus 1. The formula is as follows. So this is our new cost. Okay? So now we will have 3 steps. First of all, we will try to minimize cost prime. We will understand how to recalculate cost if you know cost prime, and why minimization of cost prime also minimizes the simple cost. So we need to understand these 3 simple things. Okay, let's start with cost prime. So notice that actually now so each ticket just increases everything what happens after it by BI. By not BI, but by 1. So actually the first ticket forces you to spend plus k minus 1 money. Yeah? So the first ticket says all your future tickets will take 1 more coin. You will buy k minus 1 more tickets, so you will spend k minus 1 more money. The second ticket increases your total money that you spent by k minus 2, etc. The last ticket increases by 0. So actually, it is k times k minus 1 over 2 more than if there was no such thing as adding some costs to tickets. Okay? So actually cost prime equals cost prime prime plus k minus 1 over 2, where cost prime prime is that you never think about the cost prime prime is no ticket increases the prices of your future tickets. So cost prime prime is just find the minimum possible cost. So this is kinda easier. Yeah, cost prime prime is kinda easier because it is simply take the sorted prices, A1 is at most A2 is at most A3, etc. And you take as many tickets as possible here, then as many as possible here, then as many as possible here. Something like m times A1 plus etc. plus A k over m, and plus something residual, which is A k over m plus 1 times k mod m. Something like this. You can find it in linear time by sorting this array. So cost prime prime is very easy to calculate. This is also very easy to calculate. So actually now your cost, let's rewrite it. Cost is cost prime plus k minus 1 over 2 minus sum of bi minus 1 bi over 2. Great. So we now know how to minimize this number. However, we need to minimize this number. We need to minimize this number, which is not just this cost prime, but also plus this and minus this. However, this is a constant. So actually, if we are able to simultaneously minimize this number and maximize this number, then we're good. Why I'm talking like that? So actually, sometimes you need to maximize some value, like a plus b. And it might be tricky. For example, if I draw it like this, yeah, so this axis stands for a and this stands for b. For example, your graph of possible pairs a, b looks like this. In this case, the point is somewhere here when you maximize. This is because a and b have some really hard to understand relations. Yeah, you cannot just simultaneously maximize a and maximize b. However, in some problems you can. For example, if your graph would be not like this, but if your graph were not like this, but it was like this, then you can simultaneously maximize a, it is here, and maximize b, which is here. So you just have this point, you take it and you win. So when actually the global maximum of a and global maximum of b are consistent with each other, so it is possible to get both global maximum of one and of the other, then the global maximum of their sum is also can be reached in the same point. This is what we have in our problem. So I have the difference of two numbers, so basically I want to minimize this number and I want to maximize this number. If they had some strange and sophisticated relations, then I would have to somehow look at their joint distribution, understand how to minimize one while maximizing the other with respect to their difference. However, actually, you can, in this particular problem, you can find the global minimum of the cost prime, the global maximum of the second thing, and they are completely compatible with each other. So as I said, cost prime is minimized when you take as many tickets as possible from the minimum a1, then as many as possible from the minimum, the second minimum a2, then as many as possible from the third minimum a3, etc. Let's try now to maximize this number. Actually, the function x minus 1 x over 2 is convex. So its graph looks like this. What does it basically mean? This means that you always want, so if you take two, let it be f. So if you have f of x plus f of y, and you want to maximize this value, you want, for example, let's assume that x plus y is constant. Again, so you have some function f which has this formula. Your objective is f of x plus f of y. X plus y is constant, and you want to maximize x plus y. Actually, in order to do that, you need to take x and y as far as possible from each other. This is a common property of all convex functions. There are a lot of ways to prove that. For example, you can just write formula. You can say that x minus 1 times x over 2 plus y minus 1 times y over 2 is x minus x squared over 2 plus y minus y squared over 2. Then you say that it is equal to x plus y over 2 minus x squared plus y squared over 2. Then you say that it is x plus y over 2 minus x squared plus 2xy plus y squared over 4 and minus x squared minus 2xy plus y squared over 4. Yeah, you can notice that 2xy and 2xy have different signs there, so they cancel out. And here we have 1/2 of x squared, and here we also have 1/2 of x squared. So indeed, the left hand side equals to the right hand side. But now you can see that it is x plus y over 2 plus x plus y squared over 4 minus x minus y squared over 4. Okay? So this is constant. This is also constant. And you want to minimize this number. Yeah, because you want to minimize the total sum. So you want to maximize this number. In order to maximize this number, you want to maximize the difference between x and y. So this is why you want them as far away as possible. The second way is to say that this is simply f of x plus f of s minus x, where s is a constant. Then you can, for example, take the derivative, or you can just make the same calculations as I did. But one way or another, you understand that this is a convex function, and you want the values of this convex function to be as far away as possible. So actually, so you have a lot of b's, b1, b2, etc., bn. You want them as far as possible. You want them to be as far as possible. However, there are restrictions. You cannot get your numbers less than 0, and you cannot get your numbers bigger than m. What is the best way to make your numbers as far as possible within these intervals? So actually, this is the optimal way. You want some numbers to be zeros, you want some of numbers to be m's, and at most one number can be neither 0 nor m. So something in between. Why is that? If you have two numbers in between, yeah, then you can move them apart from each other and make this sum even bigger than it was. So actually, you can only have one number which is neither 0 nor m, and actually the number of m's is uniquely determined. Yeah, it is simply k over m floor, and bi is some residue of k modulo m, and the zeros is simply n minus the number of these numbers. So since you have understood that there is only one number, at most one number, which is neither 0 nor m, the rest of your picture is uniquely determined. Oh. The rest of the picture is uniquely determined. Okay, so what you want is make as many m's as possible and in the end one residue. But actually it is exactly what you get when you take this greedy approach, yeah, as I said, when you want to minimize this cost prime function, you take as many minima a first as possible, then as many second minima as possible, then third minima, etc. minimum. And actually, this exactly reaches this configuration when you have a lot of m's and then the residue. So actually, this is what you need to do. You need to sort all AIs, take them greedily, and calculate the answer. So I hope that was understandable. Problem D. Bind jewels. Oh, this was a disaster. I can't greedy. Is there at least one problem which is not greedy? Problem E is also greedy. I don't remember. Ah, it's also greedy. Yes. This is just a greedy algorithm. Okay, bind jewels. So Alice wants to buy, Bob wants Alice to buy exactly K jewels. However, the strategy of Alice is not as refined as you might expect. Instead of just buying the jewels that she needs, she applies a greedy strategy. Bob chooses, first of all, Bob chooses at most 60 prices. Yeah, at most 60 prices, P1, P2, P3, etc. P60. What does Alice do? She comes to the first price and she buys, she has N coins and she wants to buy in the end K jewels. She buys as many jewels as possible. So she gets N over P first jewels, and she spends this much money. And she only has this number of coins remaining. After that, she does the same with the second stall. However, instead of having N coins, she now only has N mod P1 coins. Then she proceeds with P3, etc. P60. And Bob's objective is to make Alice buy exactly K jewels. Okay, for me it was somewhat constructive algorithm, yes. I wasn't able to prove it during the contest, but I felt like it should work, so I just submitted and got accepted. So let's think. Alice has N coins, and she needs to result with K jewels. So if N is less than K, actually it's definitely impossible. Yeah, it's definitely impossible. So what if N is at least K? So not at least K, what if N, yeah, if N is at least K. For example, if N equals K, then it's definitely possible, because we can just take stall 1. Actually, always when N is divisible by K, then we can. However, this is a step in the wrong direction. We will not usually just use the fact that N is divisible by K. Instead, let's say that we want in the end to have stall number 1. Yeah, so Alice in the end definitely spends all her money. Then we want to understand, can we somehow modify the number of Alice's coins in the beginning so that when in the end she comes to the last stall with 1, she spends exactly as much money as needed and gets exactly as many jewels as needed, K. For example, let's try and put here one stall AI. Okay, not AI, let's call it somehow A1, yeah, or P1, let it be P1. So what happens then? Alice spends n over P1 times P1 coins, and then she gets P1 jewels, and then she spends the rest of her money on the cheap jewels. So she spends all her money, definitely. How many jewels does she get? She gets n over P1 jewels plus n mod P1. Okay, so this is how much she gets, how many. Let's concentrate on the case when this is 1. So my aim is to get P1 equals 1. What do I want then? So I want this to be equal to k. Since this is 1, there are two things that I want. First of all, I want that n mod P1 was equal to k minus 1. The second thing that I want is that this is 1. How to check that it is 1? So I want P1 to be at most n. However, I want 2P1 to be greater than n. So this is my set of restrictions. Okay? Let's understand how to satisfy them. Actually, since n over P1 is 1, this is simply... So I can leave it like this, yes, but I definitely know for any number n that n is always n mod P1 plus P1 times n over P1. So this is known for any number n. So since I know that this is 1, I can find out that actually this is just n minus P1. So we get the following system. N minus P1 is k minus 1, P1 is at most n, and 2P1 is greater than n. Let's rewrite the first equation. We know that P1 is equal to n minus k plus 1. Let's rewrite it even more. So I want P1 to be equal to n minus k plus 1. So I want n minus k plus 1 to be at most n, and 2 n minus 2k plus 2 to be greater than n. And again, let's rewrite it. So P1 is equal to n minus k plus 1. This equation, not equation, but inequality is obvious, so let's ignore it. And this simply says that 2k is less than 2k, maybe let's say for n. n is greater than 2k minus 2, or at least 2k minus 1. So if n is at least 2k minus 1, you can always take this P1. And you spend n minus k plus 1 coins on the first step, and then you spend k minus 1 coins on the rest of the steps, and win, because in total you get k jewels. Notice that this inequality is actually important, because for example, if n is less than 2k minus 1, then you will spend more than n minus k plus 1 coins on the first step, and this will become a disaster. For example, if n equals 6, I think, let's try k equals 4. So notice that n is less than 2k minus 1, because 2k minus 1 is 7, and n is 6, is equal to 6. Because of that, you cannot take P1 equals n minus k plus 1. So, for example, assume that Alice has 6 coins, and you try P1 equals n minus k plus 1, which is equal to 6 minus 4 plus 1, which is equal to 3. Then you expect Alice to buy exactly 4 jewels. However, she will buy 2 jewels, not 4, because she spends the first 3 coins on the first jewel, and then she spends another 3 coins on the second jewel. You expected her to buy them separately, but unfortunately, this number is too small compared to n, and she will buy more than one first jewel, and because of that, you will not get the answer. So the main concern during the contest was the following. So I solved the problem when n is less than k. No solution. Impossible. So I solved when n equals k. You can just take 1. I can solve the problem when n is at least to k minus 1, because you can take n minus k plus 1 and then 1. But here we have a gap. What about n from k plus 1 to k minus 2? I was able to prove, I think, for n equals k plus 1, that it is impossible. Yeah, so if n equals k plus 1, then impossible. Yeah, and it was kinda easy. However, during the contest, I somehow panicked and decided to not prove it, and in the end it was kinda correct decision. However, it shouldn't be hard to prove that if you are here, then you lose. Yeah, let me try again, I think. So assume that we have some n from k plus 1 to k minus 2. We want to prove that we cannot end with k jewels. I got it. I know why you cannot get. Yeah, I understand. So this is kind of easy. This is really easy reasoning why you cannot end up with k jewels. So assume that your n is between these two numbers and you ended with k jewels. Let's say that a jewel is cheap if it costs you 1 coin. Okay? Then actually you spend some money on cheap jewels and you spend some money on expensive jewels. Okay? Let's find out how much did we spend on the expensive jewels. Yeah? So for example, let's say that we spent... So C of the jewels were cheap and E were expensive. What do we know then? So C jewels were cheap and E jewels were expensive. First of all, we know that C plus E equals K. Okay? Makes sense. Moreover, we know that C... So how much did they cost? Yeah? Let's find out how much they cost. Not cost, let me think. Actually, yeah, I want to understand how much they cost you. Okay, maybe the easiest thing to prove. Yeah, I think I understand. So notice, let's calculate how much money we spent. For example, let's say that the cost of this jewels were D1, etc. DC, and here they were F1, etc. FE. Then you know that sum of DI for I from 1 to C plus sum of Fi for I from 1 to E equals N. Well, okay, at most N. It is at most N. Yes. Now you might notice that each of these coins cost one. Each of these jewels cost 1 coin. So here we have 1. Here, all these jewels cost at most 2. So if we replace it with exactly 2, then it's also at most 10. Because it is even less. Now we can simplify it as 2 as C plus 2E. Actually, I don't like it like this. But okay. It is at most N. What do we do now? Actually, I think we want to add here this inequality. Let's take this inequality again and add it here. Yeah. So let's add the fact that C plus sum from E equals 1, I equals 1 to E, Fi is also at most N. Let's add them up. You can add two inequalities if the sign directed in the same direction. So you get 2C plus 2E plus sum from I from 1 to EFI is at most 2N. This means, so notice that 2C plus 2E, as you know, equals 2K. So the sum from I equals 1 to EFI is at most 2N minus 2K. Okay? we got that the total amount of money that you spent on the expensive jewels is at most 2n minus 2k. Yes? What do I do then? For instance, I can say that I want to say that this is at most n over 2. I think this is what I want to say. I want to say that I spent at most n over 2 money. Let's understand why this is at most n over 2. Well, to understand that, let's just understand this inequality. I want to understand that this is true. Let's multiply it by 2. So 4n minus 4k is at most n. So 3n is at most 4k. So what do we know about n? We know that n is at most 2k minus 2. Well, no, it didn't work out as I wanted, sorry. It didn't work out as I wanted. I think we can do it another way, maybe. Yeah, maybe we need to do it another way. So this was 2 cores, I think. Let's try to take this inequality. C plus sum of f's is at most 10. Okay? So we know that sum from O1 to E of fi is at most n minus c. Yeah, what can I say then? How to prove this nasty inequality? Hmm. C plus amount of money that they spent on big guys is at most 10. Yeah? Well, I liked the n2 minus k. Or 2k, yeah, 2k. It was 2k. Yeah, I understand what's the problem. Okay, I think what I want to prove is the following. So assume that n is from k plus 1 to 2k minus 2. Here. So I want to prove that the first, let's look at the first jewel that Alice buys. Yeah, if she buys no jewels, then she lost. She is lost. So if the price of this first jewel that she bought was 1, this means that she bought at least n, so at least k plus 1 jewels. And this is bad because she should have bought k jewels. So P1 is at least 2. Then she spent a lot of money actually. Yes, so she bought P1 jewels, and now she has n mod P1 money. Therefore, she can buy at most this many jewels now. She cannot buy more than this number of jewels because of that. Okay, and she needs to buy at least k jewels. Well, I will prove to you that there is a problem with this. Actually, no, it is not P1, it is n over P1. Okay? So actually, I want to say to you that she wasn't able to buy so many jewels. She wasn't able to buy so many jewels. I think it should be quite straightforward case consideration. So actually, let's consider the case when this is at least 2. I think this should work. So let's consider the case when this is at least 2. Yeah. So if this is at least 2, then so actually notice that since she bought at least 1 jewel, this is at least 1. So first of all, we consider the case when this is at least 2. This is at least 2. Then, what can you say about this number? This number is simply let me think. This number is at most, well, it is at most P1. This is less, even strictly less than P1. You can definitely say that this is at most P1 minus 1. So since she bought K jewels, yeah, and this is at most P1 minus 1, then N over P1 is at least K minus P1 plus 1. So we know this inequality. Then, actually, if we just divide N over Py, this is without the floor. This is also at least K minus P1 plus 1. Then we can multiply it by P1 and get that N is at least P1 K minus P1 squared plus P1. Or I don't like it. Well, yes, I don't necessarily like it. Well, let's try without it for now. Ah, I see what I want to say. Let's consider the case, the first case, when P1 equals 2. Okay? Let's consider the case when P1 equals 2. This case means that this number is just N over 2. Okay? But this number is at most 1. So in total we get at most N over 2, which is K minus 1 and plus 1. So this is at most K, right? Well, if you want it to be exactly K, then both of these things should be equalities instead of inequalities. So this should be exactly 1 and this should be exactly K minus 1. So if you know this number and you know this number, you can actually find out that since this is K minus 1 and this is 1, in total you get 2K minus 1, but this is greater than this number. So actually you cannot get both ratio of K minus 1, quotient of K minus 1 and a residue of 1. It's impossible. So P1 equals 2 does not give you what you wanted. Okay? Okay, the second case. So P1 is at least 2, so P1 should be at least 3 now. Now let's consider the case when P1 is at most what? At most, I think at most k minus 1, I think. So p1 is at most k minus 1. Okay? Well, actually, that means that you have something like n over p1 and n mod p1. Oh, I don't like it. Sorry, I don't like it. For now, let's do it the other way, I think. Let's do it the other way. Let's consider the case when p1 is at least k. Then n over p1 is at most 2k minus 2 over k. But this is actually equal to 1. And n modulo p1 because of that, it simply means that it is equal to n minus p1. But this is at least, is at most 2k minus 2 because of this n, and p1 is at least k, so minus k. So this number is at most 1, and this number is at most k minus 2. So in total you get at most k minus 1, and this is sad. Okay? Okay, now the third case when p1... Okay, let's consider the case when p1 is exactly k minus 1. I think it is important. I think it might be important. Then actually, n over p1 is at most 2k minus 2 over k minus 1, which is actually 2. And n mod p1 is n minus 2 p1 it is either n minus p1, which is at most k minus 1, or n minus 2 p1, which is at most 0. So actually choose what you want. So if you want actually no. Actually you can always say that n mod p1 is less than p1, which is equal to k minus 1. So this is at most k minus 2. Yeah, so p1 is at most k, n mod p1 is at most k minus 2. So if you want, again, as I said, you have numbers n over p1 plus n mod p1. This is at most k minus 2. So you want this number to be at least 2. But since it is at least 2, it is here, there is only one case when this is exactly 2. It is when n equals to k minus 2. Unfortunately, this means that, yes, this quotient is 2, but this residue is 0, yeah, because 2k minus 2 is divisible by k minus 1, so this residue is 0. So you cannot, again, you cannot get exactly k. Now you have the only one remaining case when finally 4 is p1 is from 3 to k minus 2. Again, let's look at n over p1 plus n mod p1. Actually, I think that it should be quite straightforward why this is quite a small number. Well, I think so, at least. Well, actually, to prove that, you need to understand. So previously I was saying that if you have some convex function, and you want to maximize f of x plus f of y, then you want x and y to be as far as possible. Actually, here we have the same thing. This is at most n over p1 plus n, like plus p1 minus 1, okay? This is a convex function also. You can determine this by taking the derivative of this function. It is a convex function. So, I mean the function okay, it's not clear what I meant here, I think. At this time I mean that f of x equals n over x plus x minus 1. It is a convex function. So if you want to maximize it over some segment, then you definitely want to take one of its endpoints. So if we want to maximize this expression, we want to try only p1 equals 3 and p1 equals k minus 2. Let's try both of them. So if we try 3, then we get n over 3 plus 2 at most, which is at most 2k minus 2 over 3 plus 2, which is at most 2k plus 4, 2k plus 4 over 3. Oh, well, I state that this is indeed less than k because k is greater than 4. Actually, this is easy to understand, because if k is at most 4, then this segment is empty. But I already proved to you that everything outside this segment is not the answer. This segment is not empty, so k minus 2 is at least 3, so k is at least 5, that's why you get this inequality. Okay, so if we put here 3, then this value is too small, and this is indeed also too small. Now let's consider the second case, k minus 2. So we have n over k minus 2 plus k minus 3. Well, actually, maybe... Well, it should be 5. So, let's find what it equals to. So this is at most 2k minus 2 over k minus 2 plus k minus 3. The standard thing that you can do here is take the integral part. So you can say that if this is equal to 2k minus 4 plus 2. Then this is equal to 2 plus 2 over k minus 2 plus k minus 3. So I state that this is less than k. To prove that, we need to prove that 2 over k minus 2 is less than 1. And to prove that, you need to prove that 2 is less than k minus 2. And for that, you need to understand that k is greater than 4, and this is the same thing as previously. The same thing as I said here. This is because k is at least 5 in this case. Okay, so we proved it. Maybe there's something written in the editorial about this inequality. I don't know. Let's see. Okay, they were able to write it quite elegantly. Well, problem E, no palindromes. You're given a string S consisting of lowercase Latin characters. You need to partition it into non-palindromes. Actually, for some reason I thought that I already saw this problem, however it was not the case. I don't remember this problem, yet it is quite straightforward. You have a string S. What is the easiest non-palindrome that you can think of? The easiest palindrome is just two non-palindrome, is two different letters. However, two different letters are not always available to you. For example, if you want to try a greedy approach and you see something like this, then yes, you can take these two ABs into a single string, but after that you lost. You're lost because all these characters have to form a palindrome, unfortunately. So in order to fix that, I will say that our main non-palindrome looks like B. So several equal letters, maybe one, but not 0. And then some other letter. If we... So let's just try to partition our string S into such strings. How do we do it? We do it greedily. We start with... So we take the first symbol. We take as many equal symbols as there are in this string after this A. Then we take the first element after these A's. We say that this is our first non-palindrome. Then we take the next element, for example C. We again wait until the C's are over. Then we take the next symbol, which is D, which is not equal to C, and we continue. Let's do that until the string ends. Notice that everything except the last one string are definitely not palindromes. So if the last one is also of this form, a lot of equal letters and then something else, then we won. However, sometimes this is not the case. Unfortunately, it is possible that in the end you got AAA and that's it. Maybe only one symbol, but maybe several equal letters, and then there was no other letter. Okay, so you have a lot of strings, and the last of them is not palindrome. All are not palindromes, but the last is maybe a palindrome. If it is not a palindrome, we win. We output this answer. So now we consider the case when the last thing is a palindrome consisting of equal letters. And now there will be a lot of cases. So, okay. Let's enumerate our blocks from right to left. So this is block 0, this is block 1, this is block 2, this is block s-1. So first of all, if B0 is not a palindrome, then win, because output this answer. Okay, this is easy. The second case is when s equals 1, so we have only one block. This means that we only have equal letters. And this means that we definitely will have a palindrome. Actually, any substring of this string is a palindrome. So we definitely lose if s equals 1. Now we consider the case that that we have some block of a's, and before that there is also something. There is block b1. Let's write with red something that we know because nothing of the previous cases took place. So since we know that the first case did not take place, we know that B0 is some letter A repeated k times, where k is some number. And since s is not equal to 1, we know that s is at least 2. Okay, the next thing is, let's look at B1. Actually, what I want to try is to merge B0 and B1. So let's check the second possibility, which is B1, B0 is not a palindrome. This is a win, actually, because we can just merge the last two blocks, or if we enumerate them from right to left, then the first two blocks, or name them however you want. But if this is not a palindrome, then we win. Great. How do you check that it is not a palindrome? First of all, you need to check that this. So let me write. First of all, it might be not a palindrome if B1 starts not with A. So this is a different symbol. Or it might be starting with A, however the number of A's is not the same as here. So for example, here we have 3 A's, and here we have 2 A's and 1 B. You have A, B. So how do we understand that this is a palindrome? If B1 is B1 0 is A, and if B1 dot length equals k plus 1. So if this is not equal to k plus 1, if it is not equal to k plus 1, then it is definitely not a palindrome. So this is what we need to check, and if both checks failed, then we know that B1 is simply a to the power k and then some symbol b. So unfortunately we found out that there are exactly 3 a's, same as here. Okay, now let's consider the case that S equals 2. So there are only 2 blocks. Then they look like this. We have k A's, then we have a B, and then we again have k A's. Unfortunately, this means that we lose. Because no matter what you do with a string, you will get a palindrome. So how do we prove that? If you take exactly one substring, then this is the whole string, which is a palindrome. If you take at least 2 strings, then at most one of them contains the letter B. So at least one of them does not contain the letter B and thus contains only A's. But if a string contains only A's, it is a palindrome. So no matter what you do, you will get a palindrome. Unfortunately, you lose. So in case S equals 2, you lose. So now with the red pen, we draw that S is at least 3. So we know that there are at least 3 blocks. Okay, now in the same manner as in the case 3, we can check that B2, B1, B0 is not a palindrome. This is also a win because we can merge these 3 blocks. Again, it can be checked simply as B2 is not equal to B1. So if B2 equals B1, this will be a palindrome, but if B2 is not equal to B1, it is not. So now we know that B2 is B1 is equal to B1. Well, actually, what can we do next? Next, we can actually sometimes, even if B2, B1, B0 is a palindrome, we can win. For example, look at this case. A, B, A, B, A. In this case, yeah, this is a 2 equal strings and then the same block of A's. However, the string can be divided into non-palindromes. You just need to choose any place here, except this one, and except this one. Then you need to draw a line there, and here you go. You have 2 non-palindromes here and here. Actually, it is possible always when k is not 1. Because if k is not 1, then there is an empty place between 2 A's where you can make a separation point. So if k is at least 2, then you can make, for example, a to the power k be a separation, a to the power k minus 1 be a to the power k. So this is a win. So if we still lose, then k equals 1. Actually, that means that your blocks look like this. So we have, in the end, we have AB, then AB, then A. This is what we have. Then let's find the first one, B, which is not AB. So there exists block I, which does not equal B1. So let's find the minimum one. So we have something and then a lot of ABs. Actually, that means that this is not a palindrome, because it's definitely not a palindrome. So if you want it to be a palindrome, firstly, it needs to start with A. Secondly, if you want it to be a palindrome, so then there are some A's, but notice that there can't be more than one A, because otherwise this blocks this palindrome. So actually, immediately after A, there should be B if you want it to be a palindrome. But if it is B, then actually this block equals B1. And that means that you lost. So actually, if you find min I such that this block is not AB, then this is not a palindrome, and you win. So you just merge all blocks which are ABs, the last A, and this not AB block. You merge them and you get a non-palindrome. So now, unfortunately, we have the case where all BI starting with 1 are equal to B1 are equal to AB. So actually we have a string AB, 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 ABA. So case 8, which is the remaining case, is A and B alternate, and length is odd. Actually, that means that we lose. Why is that? Because so we have an alternating string which is of odd length. This means that if we divide it into several substrings, we will definitely have at least one odd. Yeah, because if all of them are even, then the total length is also even. But this is a loss, because if this is an odd substring of this string, this is a palindrome. This necessarily starts with the same letters, and the second from the end are also the same, and the third from the beginning and from the end are the same, etc. So this is a palindrome. So we lose. So these 8 cases just give you the solution. Let's again look what the official editorial gives us. So it says that we need to check the whole string if it is a palindrome or not. It says that we need to check if all letters are the same, and we also did it. They take the first string same as we did. But after that, they notice that the whole string is palindrome and this suffix is a palindrome, and that means that this string is of this form. So AB, AB, alternate. And then they consider kind of the same cases. So if we have this thing, then the answer is no. Yes, we also consider this. If we have this, this is also no. Otherwise, we can break this pattern somewhere in the middle and win. So we should take the block of A's which is not the first and the last, and which consists of at least 2 A's. If these both occasions take place, then we can divide it into 2 non-palindromes. So actually this solution always divides the string into 1 or 2 non-palindromes. Or says that I mean, all partitions are of size 2 in this solution, and yes, they commented that it's unfortunate. Well, I think it's fine, because even if it is true, it's not what you think immediately about. Inversion composition. This is a standard problem on discrete continuity. So, as I already said in some of the previous explanations of rounds, sometimes you have a function f from integers to integers. And moreover, you know that f of x plus 1 is not very much different from f of x. For example, it is at most c. Yeah, in the most basic case, at most 1. This means that it actually always visits all values from f of L to f of R. So if L and R are some points and the function is defined between them, and if it is a discrete continuous function, then it always visits all numbers between f of L and f of R, just because it cannot jump over it. Yeah, if we have a line, imagine that it is like a river. So it's a river of width 2, and you can jump only by 1. So the most wide jump you can make is 1, the widest. Because of that, you cannot jump over this river, but somehow you get to the other side. You was under the river, and in the end you are above the river. That means that at some moment you had to jump over the river or stand inside it. And since you couldn't jump over it, then you definitely stepped inside it, and this means that you visited all values. So why is it important in this problem? Because first of all, you can prove so what do I want to say? I want to say that we want inv q plus inv pq qp, yeah, qp, to be equal to some number t. Well, actually, first of all, notice that this is, it has the same parity as the parity of q. Yeah, q, each permutation has some parity. So this has some parity of pq, which is equivalent to parity of p plus parity of q. So these two cancels out, and actually this should be equivalent to p modulo 2. So first thing that you need to check is that if you take just any permutation q, for example id, then it minimizes, no, it not minimizes, it should be the same parity as t, not t but k which you want to achieve. So if you get some different parity, then you immediately can say that the answer is no. Now let's assume that the parities coincide. Now there is an interesting fact that if you take q equals id, then you minimize this sum. And when you take q equals inverse permutation, not inverse permutation of id, but just n minus 1, n minus 2, n minus 3, etc. 0, then you maximize this number. I wasn't able to prove it. I understood that this is true. Tutorial and implementation. Okay, you can read this editorial. They prove that actually ID minimizes and inverse ID maximizes this function. You can understand it from this. Okay, I had time complexity O of n log squared n, unfortunately, but sorry, if you want exactly n log n, then you need some more observations, which I will not cover in this tutorial, sorry. Okay, as I said, from tutorial you can understand that this is minimized when Q is ID, and it is maximized when Q is a reverse of ID. Then actually I claim that I can find a sequence of permutations Q0, Q1, Q2, etc. Qn or Qt, I don't know, such that this is ID, this is the reverse of ID, and between each pair this sum changes by at most 2. So plus minus 2, plus minus 2, plus minus 2, etc. Then if you consider this sequence as a discrete function, so inv qx plus inversions of qxp, then this function is discrete continuous in the way that here we have 2 instead of 1. But there's also some sort of discrete continuity on the numbers of the same parity. So this is a discrete continuous function. If we choose appropriately this sequence Q, then you can simply run binary search on this array and find exactly the place where you get this equality. So the question is, first of all, why is it discrete continuous and how to construct this thing? So what actually will not generate them all by once. So what we need is, given a number, return a permutation with this number. Okay. First things first. I will explain it for the case when we have f of q and f inv of q plus inv not of qp but of pq. So wi equals p of q of I. Okay. Let me think. No, actually, it doesn't work like this for some reason. For some really strange reason. It does not work like this. Let me think. Well, doesn't matter. So, well, it's strange that I understood it somehow. No, it should be possible to understand. Yeah, I think it's understandable. Okay, so again, let's consider this function inv of q plus inv of pq. So there are some transpositions called elementary transpositions. This is when you take your permutation and swap two adjacent elements. Note that they always only change the number of inversions by one. Yeah, if some element here had some inversion with element here, it is not changed. If some element here had any inversions with here or here, they are preserved. The only thing that could change and will change is the order of these two elements. This is flipped. So you either get +1 or -1. So each time you make an elementary swap, this gets +-1. Moreover, this thing also gets +-1, simply because for the permutation PQ, it is also an elementary transposition. Since you swapped QI and QI +1, you also swapped PQI and PQI +1. So what is an elementary transposition for Q? It is also an elementary transposition for PQ. So it is also +-1. However, in our statement, unfortunately, we have QP. So what to do? Actually, you can make elementary transpositions to Q-1, to inverse Q. Because notice, actually, for any permutation, the number of inversions in it equals the number of inversions in the inverse permutation. Similarly, the number of inversions in QP is the same as the number of inversions if in P-1, Q-1. And this time, if you change Q-1 with elementary transpositions, this is also changed with elementary transpositions, and thus this is changed with elementary transpositions. So if you apply elementary transpositions to Q-1 one by one, you get the correct answer. So let's find out how we transpose with elementary transpositions Q-1 from ID to reversed ID. This is quite straightforward. So initially you have 1, 2, 3, etc. n. So let me, for example, write it not the way I used to do during the contest. So first thing that we do is we put 2 here. So we get 2, 1, 3, 4, etc. We spent 1 action. Now we can make 2 more actions. We can move 3 once and twice to the left. So, and after 2 movements, we can get this. Then after 3 movements, we can make this, etc. Each time you make a movement as a series of movements, each of these elementary movements is an elementary transposition. And in total, you will get exactly n times n-1/2 transpositions, so each of them increases the number of inversions actually. Okay, so actually so this is the sequence that you need. The question is how to restore the ith element of this sequence. You can do it in linear time. So first of all, you need to find the number of steps that you made fully. To do that, you take your number of inversions x and you start to subtract -1, -2, -3, etc. And at that moment, you cannot subtract L. You can subtract L -1, but you cannot subtract L. It is impossible. This means that all these elements are fully subtracted. So this means, I guess, that you have L, L -1, L -2, etc. 1. And then you have some residue, which is x minus L -1, L over 2. And you need to move this element to the left by x positions. This is also quite easy. You just move it. Okay, I think in the solution something similar is proposed. Yeah, because this is practically looks the same. Yeah, this is practically the same. But somehow they avoid the binary search. Okay, I don't think I will explain it to you. Finally, we have problem G, Clacking Balls. I even don't want to explain problem G because there was a long upsolving, and if you watch through it, it will be a thorough tutorial, I guess. Therefore, Amogus, and thank you for watching.